Tonight, we are going to talk about a planet that may have once belonged to our solar system. Not Pluto, not Planet 9, and not a hidden world waiting at the edge of the dark, but a giant planet that may have been thrown away completely. Today, the solar system looks calm. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all move around the Sun in stable orbits. From a distance, it looks like an ordered system, almost like it was always meant to be this way. But the early solar system may have been far more violent. The giant planets may have moved. Their orbits may have shifted. Small worlds may have been scattered into the darkness. And one planet, possibly an extra ice giant, may have been pushed too close to Jupiter and launched out of the solar system forever. If this is true, then our solar system did not simply form peacefully. It survived a disaster. And somewhere, far beyond the Sun, a lost planet may still be drifting through interstellar darkness, carrying the memory of a solar system it no longer belongs to. So tonight, the question is simple. Did our solar system once lose a planet? Before we begin tonight's journey, subscribe to the channel if you want more calm space documentaries like this. Leave a like if you enjoyed deep space mysteries, and write in the comments where you are watching from and what time it is where you are right now. Tonight, you are watching the Space for Sleep channel, talking about the planet that was thrown out of our solar system. To understand how a planet could be thrown out of the solar system, we first have to let go of one simple idea. The solar system was not always calm. Today, it looks almost peaceful. The Sun sits at the center. The planets follow their paths. Mercury moves close to the heat. Venus shines brightly in Earth's sky. Earth circles in the narrow region where liquid water can exist on the surface. Mars turns red and cold beyond us. Farther out, the giant planets move slowly through the dark. Jupiter, Saturn, Uranus, and Neptune. From our point of view, it feels organized. It feels permanent. It feels as if the solar system has always been this way. But that calm appearance may be misleading. The solar system we see today is old. Very old. It has had billions of years to settle, to lose unstable objects, to clear out dangerous paths, and to hide the violence of its beginning. What looks peaceful now may not be the original design. It may be the result of chaos that already happened long before humans existed, long before animals walked on land, long before Earth had anything like the world we know today. The modern solar system is not necessarily the first version. It may be the surviving version. That difference is important. Because when we look at the planets today, we are not watching the solar system being born. We are looking at the aftermath. We are looking at the structure that remained after gravity finished its earliest battles. The missing pieces are not obvious because they are missing. The destroyed objects do not introduce themselves. The worlds that were scattered away do not leave a simple label in the sky. They are gone. And that means the peaceful solar system may be hiding a violent memory. In the beginning, the Sun did not appear alone in empty space, with 8 finished planets neatly placed around it. It formed inside a cloud of gas and dust. Around the young Sun, materials spread into a rotating disk. Tiny grains collided. Some stuck together. Larger bodies formed. They collided again. Rock, ice, gas, and metal gathered into growing worlds. The solar system was not a clock at first. It was a construction zone. And construction zones are messy. There were far more objects than there are today. More fragments, more planetesimals, more icy bodies, more young worlds fighting for stable paths. The early solar system was filled with material that had not yet found its final place. Gravity was pulling, pushing, scattering, and reshaping everything. Some objects fell toward the Sun. Some smashed into each other. Some were absorbed by growing planets. Some were thrown outward. Some may have been launched away completely. The calm orbits we see today came later. Before order, there was motion. Before stability, there was competition. This is especially true in the outer solar system, where the giant planets formed. Jupiter, Saturn, Uranus, and Neptune are not small worlds. They are massive gravitational bodies. They do not simply sit in space. They shape it. They pull on smaller objects. They disturb orbits. They exchange energy. They can move entire populations of icy bodies. They can rearrange the architecture around them. Jupiter especially is enormous compared with every other planet. It holds more mass than all the other planets combined. Its gravity is powerful enough to influence asteroids, comets, and even the long-term behavior of other worlds. In the early solar system, a planet like Jupiter would not have been a quiet neighbor. It would have been a gravitational giant capable of changing the fate of anything that came too close. This is where the story of a lost planet becomes possible. Because if the giant planets were once arranged differently, and if the early solar system contained more large bodies than it does today, then one of those bodies could have become unstable. It could have been pushed from one orbit to another. It could have passed too close to Saturn, Uranus, Neptune, or Jupiter. And if it passed too close to Jupiter at the wrong time, the encounter could have changed everything. A planet does not need to be destroyed to be lost. It only needs to be given enough speed. The Sun holds the planets through gravity. Every planet is constantly falling around the Sun, moving forward fast enough that it never falls straight in. But if an object receives enough energy, its path can stretch wider and wider. It can move into a long, unstable orbit. It can be pushed farther from the Sun. And eventually, if it gains enough speed, it can escape the Sun's control completely. That is what thrown out really means. Not picked up and thrown like a stone, but gravitationally accelerated until the Sun can no longer keep it. This may sound extreme, but gravity can do this. Planets can scatter smaller objects all the time. Comets can be sent into new orbits. Asteroids can be redirected. Spacecraft can use gravity assists to gain speed from planets. The same basic idea, on a much larger and more chaotic scale, could apply to a young planet in the early solar system. A close encounter with a giant planet can steal or give orbital energy, and Jupiter had more than enough gravitational power to become the final judge. The strange part is that the solar system may actually make more sense if something like this happened. When scientists simulate the early solar system, they do not always get the neat arrangement we see today. The giant planets may not naturally settle into their current positions without some period of instability. Their orbits may have shifted. Jupiter and Saturn may have changed their relationship. Uranus and Neptune may have moved outward. Huge populations of icy objects may have been scattered in the process. In some models, an extra giant planet helps the story work. Not a rocky planet like Earth, not a small dwarf planet like Pluto, but an additional ice giant, perhaps similar in type to Uranus or Neptune. A planet that once belonged to the outer solar system. A planet that is no longer here. This does not mean scientists have found that lost planet. It does not mean we know exactly where it went, or even that it definitely existed. The idea is a hypothesis, a possible explanation for why the solar system ended up looking the way it does. But it is a powerful idea because it changes the emotional shape of the solar system. It suggests that the system we live in may have survived by losing a world. A giant planet could have been part of the early family of the Sun. Then, during a chaotic period, gravitational interactions may have pushed it into danger. The outer planets may have tugged on it. Its orbit may have become stretched. It may have crossed paths with other giants. Each encounter could have changed its motion a little more, making its orbit less stable, more dangerous, more likely to lead to a final violent meeting. And then, Jupiter may have done the rest. Imagine a young solar system where the giant planets are not yet settled. The Sun is surrounded by debris, ice, dust, and growing worlds. Jupiter is already powerful. Saturn is nearby, on a different path. Uranus and Neptune are shifting, and somewhere among them, another giant planet moves through the outer darkness. Not yet lost, not yet safe. For a while, it might seem like just another member of the system, a cold, distant world, thick atmosphere, deep gravity. Maybe moons, maybe rings, maybe a dark blue or gray face turned toward a young sun. Then, its orbit begins to change. Not in one instant, slowly through repeated gravitational encounters. A tug from one giant, a push from another. A close pass that stretches the orbit, another that sends it farther out. The planet begins to move through a more dangerous path, crossing regions where stable worlds should not cross. It becomes a wanderer inside its own solar system. Not yet a rogue planet, but no longer safely placed. Then comes the encounter that changes everything. A close pass with Jupiter. In a meeting like that, the two worlds would not collide. They would not need to. Gravity reaches far. The lost planet would fall into Jupiter's influence, swing around it, and leave with a different path than before. Jupiter, because of its mass, would barely notice compared with the smaller giant world. But for the lost planet, the encounter could be decisive. Its orbit could become wider, more stretched, more unstable, or it could be pushed onto a path that no longer returns. The Sun's grip weakens with distance. The farther a planet moves away, the less tightly the Sun holds it. If Jupiter gives the planet enough energy, the planet can cross the invisible line between bound and unbound. It stops being a planet of the Sun and becomes a planet of the galaxy. A rogue world, a planet without a star. That is the haunting possibility at the center of this story. Our solar system may once have had another giant planet, and that planet may not have been destroyed. It may still exist, somewhere, but no longer as part of us. It may be drifting through interstellar space, far beyond the warmth of the Sun, moving between stars as a frozen relic of the solar system's violent youth. It would not appear in our sky. It would not return every few centuries like a comet. It would not wait just beyond Neptune like a hidden ninth planet, still orbiting the Sun. If it was truly ejected, then it is gone in a deeper way. It escaped the solar system. And that makes the modern solar system feel different. Because if this happened, then the 8 planets we know are not simply the planets that formed. They are the planets that remained. This is a colder way to look at our cosmic home. It means the solar system is not only a family of worlds, it is also a record of survival. Mercury survived near the Sun. Venus survived as a burning world. Earth survived in the habitable zone. Mars survived as a small, cold planet. Jupiter and Saturn survived as gas giants. Uranus and Neptune survived in the distant dark. But maybe one giant did not survive as a member of the system. Maybe it was removed. And if one planet could be removed, then the solar system's calm begins to look less like destiny and more like chance. This matters for Earth too. Earth's stability may depend on events that happened long before Earth became habitable. The arrangement of the giant planets influences comets, asteroids, impact rates, and the architecture of the outer solar system. If the early giant planets had settled differently, the inner solar system might have faced a different history. Earth might have been struck more often, or less often. Its orbit might have been disturbed. The supply of water and volatile materials might have changed. We cannot simply separate Earth from the outer planets. The whole system is connected by gravity. That means a lost planet is not just an interesting missing object. It could be part of the reason the solar system became the version that allowed Earth to remain stable long enough for life to grow complex. A planet thrown away may have helped shape the quietness that came after. That is a strange thought. A missing world may be part of why our world survived, not because it intended anything. Not because the solar system had a plan, but because gravity has consequences. One world's loss can become another world's stability. The early solar system was full of these consequences. Every collision changed something. Every close encounter changed something. Every scattered object carried energy and momentum away. The final arrangement of planets is not only a list of objects, it is a history of countless interactions, most of which happened before there were eyes to see them. Today, we see the result and call it normal. But normal is just what survived long enough for us to be born inside it. That is why the first step in understanding the thrown-out planet is not to search the darkness immediately. It is to understand that the solar system itself may be an edited story. We see the remaining chapters. We know the characters still present. But some pages may have been torn out billions of years ago. The lost planet, if it existed, would be one of those missing pages. A whole world removed from the story. And yet, even missing pages can leave traces. They can leave gaps in the logic. They can leave strange arrangements. They can leave patterns that are hard to explain unless something once passed through and changed everything. This is where the mystery becomes more than imagination. Because scientists do not propose a lost giant planet only because the idea sounds dramatic. They look at the solar system we have. They look at the outer planets. They look at their orbits. They look at the scattered populations beyond Neptune. They run models of how the solar system could have evolved. And sometimes, the story becomes easier to explain if there was once another giant planet that did not survive. That does not prove it, but it makes the absence interesting. The outer solar system is not perfectly simple. Uranus and Neptune are far away, cold, tilted, and strange. The Kuiper Belt contains icy objects that carry memories of ancient scattering. Small bodies move in patterns that suggest the outer planets once disturbed them. The giant planets may have migrated, and migration leaves marks. It is like walking into a quiet room after a storm and noticing that furniture has been moved, glass is on the floor, and the door is open. The storm is gone, but the room remembers. The solar system may remember too, not in words, not in pictures, but in orbits, in distances, in the locations of small icy bodies, in the positions of planets that should not be taken for granted. The calm we see today may be the silence after gravitational violence, and if we want to understand whether a planet was thrown out, we have to read those silent clues. We have to look not only at what is present, but at what the present arrangement seems to require. We have to ask why the outer planets are where they are, why the small icy worlds beyond Neptune are scattered the way they are, why the solar system settled into this exact architecture and not another. Because sometimes the most important evidence is not an object we can see. Sometimes it is the shape left behind by something that disappeared. That is why the outer solar system is so important. If a planet was truly thrown out billions of years ago, we should not expect to see it sitting neatly in the sky. We should not expect it to announce itself as a missing world with a label attached. A planet that escaped the sun would be gone. It would not orbit between Uranus and Neptune. It would not wait behind Pluto. It would not return every few thousand years like a comet. But its absence may still have consequences. The solar system is not only made of planets, it is made of patterns, orbits, tilts, distances, belts of small icy bodies, scattered objects that move in strange paths, gaps where something may have been disturbed, populations of worlds that look as if they were pushed, pulled, or thrown into place. These patterns are the clues. They are quiet clues, because space does not preserve history like a written record. There is no video of the early solar system, no eyewitness account, No photograph of Jupiter passing close to a lost planet. No ancient map showing 5 giant planets instead of 4. Scientists have to work backward from what remains. They look at the planets we still have. They look at the small objects left behind. They look at the shape of the outer solar system. And they ask a difficult question. Could this arrangement have happened without losing something? The first clue is the outer planets themselves. Jupiter, Saturn, Uranus, and Neptune do not feel like random objects. They are the great gravitational architects of the solar system. Their positions define much of what happens beyond Mars. Jupiter dominates the asteroid belt. Saturn shapes moons and resonances. Uranus and Neptune sit far out in the cold, marking the transition into the icy outer regions. But the more carefully we look, the less the outer solar system feels like something that simply formed in place and stayed still forever. Uranus and Neptune especially raise questions. They are far from the Sun. They are icy giants, not gas giants like Jupiter and Saturn. They contain heavy elements, ices, deep atmospheres, and strange internal structures. They are smaller than Jupiter and Saturn, but still far more massive than Earth. They are not minor worlds. They matter. Their gravity shapes the distant solar system, and yet, forming large planets so far from the Sun is difficult. The farther from the young Sun you go, the more spread out the disk of material becomes. Things move more slowly. Collisions happen less often. Growth becomes harder. Building a planet as massive as Uranus or Neptune in their current distant positions may have been much more difficult than building them closer in, where material was denser and collisions could happen more efficiently. This suggests something important. Uranus and Neptune may not have formed exactly where we see them today. They may have migrated. They may have moved outward after forming closer to the Sun. If that happened, then the outer solar system was not fixed. It changed. The giant planets shifted through a sea of small icy bodies, exchanging energy with them. As they moved, they scattered objects inward and outward. Some small worlds were thrown toward the inner solar system, some were pushed into distant orbits, some were ejected completely. Migration is not gentle. When giant planets move, the small bodies around them do not simply follow politely. They are stirred. Some are trapped. Some are scattered. Some are lost. The outer solar system becomes a record of that motion. This brings us to the second clue, the Kuiper Belt. Beyond Neptune lies a vast population of icy objects. Some are small, some are large enough to be dwarf planets. Pluto is part of this distant population. So are many other frozen bodies, most of them too faint and distant to be familiar to the public. At first, the Kuiper Belt might sound like a simple leftover region, a cold storage shelf of ancient debris from the formation of the solar system. But it is not perfectly simple. The Kuiper Belt has structure. Some objects follow relatively calm orbits. Others are locked in orbital relationships with Neptune. Some move in more stretched paths. Some are scattered far beyond the main belt. Some have orbits that suggest they were disturbed, not gently placed. The distribution of these icy bodies is like a fingerprint left by the giant planets. Neptune is especially important here. As Neptune moved outward, it could have captured objects into resonances. That means some icy bodies orbit the Sun in patterns connected to Neptune's orbit. Pluto, for example, is in such a relationship with Neptune. These resonances are not random decoration. They are evidence that Neptune's motion and gravity shaped the outer solar system over time. If Neptune migrated, then the outer solar system was once more crowded and more unstable. And if Neptune migrated, something had to drive that migration. One way this can happen is through interactions with a massive disk of small icy bodies. As Neptune and the other giant planets scattered those objects, the planets themselves shifted. This process can move planets over time. It can change orbits. It can send debris into new regions. It can even trigger instability among the giant planets. The Kuiper Belt, then, is not just a collection of frozen leftovers. It is a memory field, a region where ancient gravitational events are still written into the paths of small worlds. But the clues become even more interesting when scientists try to recreate the solar system's past. A good model of the early solar system cannot only explain one thing. It cannot only put Neptune in the right place. It cannot only explain Pluto's orbit. It cannot only reproduce a few scattered objects. It must explain many things at once: the positions of the giant planets, the structure of the Kuiper Belt, the populations of small icy bodies, the stability of the inner planets, and the fact that the solar system did not tear itself apart. That is difficult. When scientists run simulations of giant planet migration, some versions create a solar system that looks too calm. Some create one that becomes too chaotic. Some lose Uranus or Neptune. Some disturb the inner planets too much. Some fail to reproduce the pattern seen beyond Neptune. The early solar system has to be unstable enough to explain the evidence, but not so unstable that it destroys the system we have. That narrow balance is where the lost planet becomes useful. In some simulations, adding an extra ice giant makes the story work better. Not because scientists want an extra planet for drama, but because an additional planet can absorb chaos. It can interact with the other giants, change the timing of instability, and then be ejected, leaving behind 4 surviving giant planets in positions closer to what we see today. In this kind of model, the missing planet is not an afterthought. It is part of the mechanism that helps the system reach its final state. The lost planet becomes a sacrifice made by gravity. Again, this is not proof, but it is a clue. Because if the solar system is easier to explain with a missing giant planet, then the absence itself becomes suspicious. The third clue is the strange stability of the planets that remained. This may sound backwards. If the planets are stable now, why would that suggest violence in the past? But stability after chaos is common in nature. A messy process can end in a stable arrangement because the unstable parts are removed. A crowded room becomes calm after people leave. A planetary system becomes stable after dangerous orbits are cleared, collisions happen, or bodies are ejected. The solar system today may be stable partly because the most unstable member was removed. If an extra ice giant once crossed paths with the others, it could have threatened the long-term order of the outer solar system. But once Jupiter threw it away, the remaining giants could settle. Their orbits could become more widely spaced and safer. The system could calm down. The violent act of losing a planet could make the surviving architecture more stable. This is a strange kind of order. Not order because nothing bad happened. Order because the bad thing already happened. That idea changes how we interpret the solar system's calm. The calm may not be evidence against chaos. It may be evidence that chaos completed its work. The fourth clue comes from small bodies scattered throughout the solar system. Comets and icy objects often have histories shaped by the giant planets. Some come from the distant outer regions. Some travel in long, stretched orbits. Some were likely disturbed by Neptune, Jupiter, or passing stars. The solar system contains reservoirs of small icy bodies, and these reservoirs preserve hints of ancient scattering. The Oort cloud, if it exists as expected, may contain countless icy objects surrounding the solar system at enormous distances. These objects were likely scattered outward by the giant planets early in solar system history, then held loosely by the Sun and influenced by the galaxy and passing stars. The Oort cloud is not directly visible as a full structure, but long-period comets suggest that such a distant reservoir exists. This matters because it shows that the giant planets were able to throw things far away. Not just a little, far. They could send small, icy worlds into the deep outer regions. They could launch objects onto long orbits. They could contribute to a distant cloud of comets barely held by the Sun. If the giant planets could scatter countless small bodies, then the same gravitational environment, at a larger scale, could also scatter a planet if the encounters were strong enough. Of course, throwing out a planet is harder than throwing out a comet. A planet has far more mass. It cannot be pushed around as easily. But the early solar system had time, crowding, and giant planets. Repeated encounters can build consequences. A single close interaction with Jupiter could become decisive after earlier encounters had already destabilized the planet's orbit. The small bodies show us the outer solar system was not a quiet archive. It was stirred, it was rearranged, it was sculpted by gravity. The fifth clue is the arrangement of the giant planets themselves. Jupiter and Saturn have a special relationship. Their orbits, masses, and gravitational influence affect the rest of the solar system. In early migration models, the changing relationship between Jupiter and Saturn can trigger instability. When giant planets enter or cross certain orbital relationships, their gravitational effects can become stronger, disturbing Uranus, Neptune, and any additional planets nearby. This is where the outer solar system could have gone from slow migration to sudden chaos. For a long time, the planets may have shifted gradually. Then a resonance or gravitational configuration may have destabilized the system. Orbits stretched. Close encounters became possible. Ice giants may have crossed paths. Small bodies were scattered everywhere. In this phase, an extra planet would be in danger. A fifth giant planet could be pushed into repeated encounters with the surviving giants. It could trade energy with Uranus or Neptune. It could pass near Saturn. But Jupiter, because of its mass, would be the most powerful ejector. If the planet's path eventually brought it close enough to Jupiter, the result could be escape. The surviving planets would carry the memory of that event not as a scar we can see on a surface, but as an orbital arrangement. Their current spacing, their eccentricities, their inclinations, their relationship with small body populations, all of these become clues in a mystery where the missing object is gone. This is why the story feels almost like forensic astronomy. Scientists are not watching the crime happen. They are walking through the room afterward. The suspect is gravity. The missing victim is a planet. The evidence is the architecture of the solar system. But the investigation is difficult because many different histories can produce similar results. A planet may have been ejected, or the solar system may have reached its current form through a different path. The Kuiper belt may preserve one kind of clue, while the giant planets preserve another. Simulations may suggest possibilities, but the real solar system happened only once. We cannot rewind it perfectly. We can only test which histories are plausible. That is why careful language matters. We should not say the lost planet definitely existed. We should say it may have existed. It could have existed. It is one possible explanation for the strange clues left behind. But possibility alone is powerful when the missing object is a whole planet. Because if a planet can vanish from the solar system's family and leave only indirect traces, then our picture of planetary systems becomes more dynamic. A solar system is not only a set of finished planets, it is a history of gravitational survival. The planets we name are the ones that stayed. Other worlds may have formed and been destroyed, swallowed, or thrown away. Our system may be quieter now, but it was not born quiet. The sixth clue is comparison. Our solar system is not the only planetary system in the galaxy. Around other stars, astronomers have found planets in surprising arrangements. Giant planets close to their stars, super-Earths packed tightly together, systems with resonances, systems with eccentric orbits, worlds that seem to have migrated far from where they formed. The galaxy has shown us that planetary systems can be chaotic, diverse, and strange. This matters because it makes our own solar system look less like a perfect template and more like one outcome among many. Planet migration is not a wild fantasy. Gravitational instability is not a rare story invented only for our system. Planets can move, orbits can change, worlds can be lost. Astronomers have also found rogue planets, or at least strong candidates for planets not clearly bound to stars. Some may have formed alone, some may have been ejected from their systems. The very existence of free-floating planetary mass objects makes the idea of ejection feel less impossible. The galaxy may contain many worlds that no longer belong to the stars that formed them. If our solar system lost a planet, it would not be the only system capable of such a thing. It would be part of a larger cosmic pattern. Planetary systems are born from disks, but they are shaped by chaos. They settle through collisions, scattering, migration, and loss. What survives can look orderly after enough time, but that order may hide a violent past. This is the larger meaning of the clues. The outer solar system is not strange in just one way. It is strange in many connected ways. The giant planets may have migrated. The Kuiper belt carries patterns of disturbance. Small icy bodies have been scattered. The current stability may reflect earlier instability. Simulations sometimes work better with an extra ice giant. Other planetary systems show that migration and loss are real parts of planetary history. None of these clues alone forces the lost planet to exist, but together they make the idea worth taking seriously. They turn the missing planet from a fantasy into a scientific possibility. And perhaps the most haunting part is that the evidence is not a glowing world in a telescope. It is absence shaped by gravity. A planet that was thrown away would not leave footprints in dust. It would leave the solar system changed, like a missing member of a family, whose absence explains why everyone else stands where they do. This is why the story of the thrown-out planet begins with clues, not discovery. We have not found the lost world drifting in interstellar darkness. We may never find it. It may be too far, too cold, too faint, and too disconnected from the sun to identify as ours. But the solar system may still carry the shape of its departure. The outer planets may be where they are because something else was removed. The small, icy bodies may move the way they do because the giants once shifted. The quiet structure we see today may be the settled aftermath of a much more violent arrangement. That is what makes the lost planet so compelling. It is not just a hidden object. It is a missing cause. And once we start following those clues, the next part of the story becomes unavoidable. If the outer solar system really was rearranged, then the giant planets could not have stayed fixed in place. They must have moved. Jupiter, Saturn, Uranus, and Neptune were not simply born into their modern positions like pieces placed on a finished board. They may have migrated through a young solar system crowded with ice, dust, debris, and unstable worlds. And when the giant planets began to move, the entire solar system changed with them. That is the next part of the story. Because planets are not fixed decorations around a star. They are moving bodies in a gravitational system. And in the early solar system, that system was still changing. The giant planets did not simply appear in their modern positions and stay there forever. They grew inside a young disk of gas, dust, ice, and debris. And after they formed, they continued to interact with everything around them. They pulled on the disk pulled back. They scattered smaller objects. The smaller objects changed their orbits in return. Over long periods of time, these exchanges could make planets drift. Not drift like leaves on water. Drift through gravity. A planet can move inward or outward by trading energy and angular momentum with the material around it. When a giant planet scatters a smaller icy object inward, the planet can gain or lose a small amount of motion in response. One small object does not matter much, but billions of small objects, over millions of years, can matter greatly. The giant planet slowly changes its orbit, not because it chooses to move, but because gravity keeps exchanging tiny pushes across enormous time. This is planetary migration, and it may be one of the keys to understanding why our solar system looks the way it does. At first, this idea can feel strange. We are used to thinking of planets as stable. Earth has an orbit. Jupiter has an orbit. Neptune has an orbit. The planets go around the Sun in paths that seem ancient and permanent. But an orbit is not a rigid track carved into space. It is a relationship between motion and gravity. If that relationship changes, the orbit changes. In the early solar system, there was much more material available to change those relationships. The young sun was surrounded by leftover debris. The giant planets were embedded in or near a disk of icy objects. The outer solar system was not a clean, dark region. It was crowded with planetesimals, fragments, and growing worlds. Every close pass mattered a little. Every gravitational scattering moved energy around. The system was still settling into the form we see today. This means the giant planets may have once been closer together. Jupiter and Saturn may have had a different orbital relationship. Uranus and Neptune may have formed closer to the Sun than they are now. Neptune may have moved outward through a disk of icy bodies, pushing, trapping, and scattering them as it went. The solar system we see now may be the calm after that migration. To imagine this, do not picture the planets moving like spaceships firing engines. Picture a slow rearrangement across deep time. Jupiter slightly changes its path. Saturn shifts. Uranus and Neptune are affected. The disk of small icy bodies responds. Some objects are thrown outward. Some are thrown inward. Some are captured into resonances. Some are removed forever. The whole outer solar system becomes a gravitational conversation. No sound, no intention, just force, motion, and consequence. Jupiter is especially important in this conversation because of its mass. It is the giant of the giant planets. When Jupiter interacts with smaller objects, it can strongly scatter them. When it interacts with another planet, the effect can be enormous. Jupiter is not merely one planet among 8. It is the anchor of the outer solar system's gravitational power. Saturn matters too. Together, Jupiter and Saturn can shape the stability of the whole system. Their orbital relationship can amplify gravitational effects. If their periods fall into certain patterns, their repeated pulls can disturb other planets. In some models of the early solar system, a changing relationship between Jupiter and Saturn helps trigger a wider instability among the giant planets. That instability could have changed everything. For a long time, the outer planets may have migrated slowly. Then, at some point, the system may have crossed a threshold. A stable arrangement became unstable. Orbits that had been safe became dangerous. Planets began to tug on each other more strongly. Uranus and Neptune may have been pushed onto new paths. Small, icy bodies were scattered across the outer solar system. And if an extra giant planet existed, it would have been thrown into the middle of this chaos. This is why planetary migration is not just a slow, peaceful process. It can begin gradually, then become violent. A planet moving through a disk changes the disk. The disk changes the planet. Other planets respond. Resonances shift. Close encounters become possible. And once giant planets begin passing too close to each other, the solar system enters a far more dangerous phase. Close encounters between planets are among the most powerful events in planetary history. They do not need to collide to change each other's fate. Gravity alone is enough. If two planets pass near each other, each one pulls on the other. Their paths bend. Their speeds change. Their orbits around the Sun become different. The more massive planet usually changes less, and the smaller planet changes more. If the encounter is strong enough, one planet can be pushed into a much wider orbit, or even sent onto a path toward escape. This is how a planet can be lost without being shattered. It is not destroyed. It is redirected beyond return. The early solar system may have created exactly the kind of environment where this could happen. A crowded outer region, giant planets migrating, small bodies scattering, orbits shifting, resonances triggering instability, several massive worlds pulling on one another while the system searched for a stable arrangement. In that environment, an extra ice giant would be vulnerable. It would not have the mass of Jupiter. It may not have been as protected as Saturn. It may have been closer in mass to Uranus or Neptune, large enough to shape the system, but not large enough to dominate it. If its orbit became unstable, repeated encounters could push it farther and farther from safety. This is the important part. A planet does not need to be ejected in a single clean event from the beginning. It may first be destabilized. Its orbit may become stretched. It may cross the paths of other planets. It may survive several encounters, each one changing its orbit. Then, after enough chaos, one final encounter can finish the process. Jupiter may have been that final encounter. But before Jupiter could throw anything away, the system had to become chaotic enough to bring the planet near Jupiter in the first place. That is where migration matters. When Neptune moves outward, it does not move through empty space. It interacts with icy bodies. It captures some into resonances. It scatters others. It changes the shape of the Kuiper belt. It helps explain why some distant objects have the orbits they do. Neptune's movement is like a plow passing through a frozen field, leaving patterns behind. But Neptune's migration also depends on the earlier arrangement of the giant planets. If Uranus and Neptune were once closer to Saturn and Jupiter, their interactions could have been more intense. They may have exchanged places or been pushed outward in stages. The outer solar system may not have always had the neat order we see today. There may have been a time when ice giants crossed paths, when their orbits overlapped, and when stability was only temporary. That kind of system cannot last forever. Something has to give. Either planets settle into safer paths, or one of them is removed. This is why the idea of a fifth giant planet is so powerful. In a chaotic early solar system, an extra ice giant can act almost like a pressure release. The system can go through violent interactions. One planet can be ejected, and the remaining four giants can settle into a configuration closer to the one we see now. The missing planet becomes the cost of stability. Without it, some simulations struggle. The surviving planets may not end up in the right places. Uranus or Neptune may be lost instead. Jupiter and Saturn may disturb the inner solar system too much. The system may not calm down in the way it needs to. Adding a fifth giant planet gives gravity another body to remove, allowing the rest of the system to survive. This does not mean the fifth planet definitely existed, but it shows why scientists take the idea seriously. It is not only a mystery about a lost world, it is a possible solution to a problem of architecture. The solar system today has four giant planets. They are spaced in a way that has remained stable for billions of years. But getting from the early crowded disk to this stable arrangement may not have been simple. Planetary migration may have required instability. Instability may have required loss, and the lost object may have been a planet. If this is true, then the movement of the giant planets was not a minor adjustment. It was a turning point in the history of everything that came after. Because when the giant planets moved, they did not only affect themselves, they affected the small bodies around them. They affected the outer disk. They affected comets. They affected impact rates. They may have affected how material moved toward the inner solar system. They may have affected the conditions that later mattered for Earth. The entire solar system is connected by gravity. Even across enormous distances, a change in the outer planets can send icy objects inward. It can disturb reservoirs of comets. It can change the flow of debris. It can alter the rhythm of impacts on planets and moons. The planets are not isolated marbles, they are part of a dynamic system. That is why the migration of Jupiter, Saturn, Uranus, and Neptune may have left marks across the whole solar system. Some marks may be preserved in the Kuiper Belt, some in the orbits of distant icy objects, some in the populations of comets, some perhaps in the cratered surfaces of moons and planets, some only in the fact that the surviving planets are arranged as they are. But the most haunting mark may be the absence of the planet that did not remain. To understand how dramatic this migration could be, imagine the early outer solar system as a crowded, frozen region beyond the young giant planets. Countless icy bodies orbit the Sun. Some are small, some large, some perhaps hundreds or thousands of kilometers across. The giant planets sit closer together than they do today, not yet in their final positions. At first, changes are gradual. Neptune scatters icy objects. Its orbit shifts outward. Jupiter may move slightly inward as it sends objects away. Saturn changes its relationship with Jupiter. Uranus and Neptune respond to the changing gravitational pattern. Then, the balance breaks. The giant planets enter a period of stronger instability. Their orbits become more eccentric. They pull on each other more violently. Ice giants swing through regions where they should not remain. The disk of icy objects is disturbed on a massive scale. Some objects are flung inward toward the giant planets. Some are sent outward into distant reservoirs. Some are trapped in resonances. Some are ejected from the solar system entirely. And somewhere in that chaos, a fifth giant planet, if it existed, begins losing its place. It is no longer safely embedded in a stable path. It becomes a traveler through a dangerous system. Each pass near another giant changes its fate. A close encounter with Neptune may shift its orbit. A pass near Saturn may stretch it further. Another interaction may push it inward or outward. Then, Jupiter waits as the most powerful body in the planetary system. The final encounter may have been brief compared with the age of the solar system, but its consequences would be permanent. The lost planet would approach Jupiter on an unstable path. Jupiter's gravity would bend that path sharply. The planet would leave the encounter with more energy than before. Its orbit around the Sun would become so stretched that it may no longer close. The planet would begin escaping, not instantly vanishing, not disappearing in a flash, but moving outward farther and farther from the Sun, on a path that no longer belongs to the solar system. For a long time, the Sun would still be visible from that planet. Jupiter would become smaller behind it. Saturn, Uranus, and Neptune would fade into points. The young solar system would shrink into a distant region of light. Then, the lost planet would cross into interstellar space. From then on, it would not orbit the Sun in the ordinary sense. It would move through the galaxy as a free-floating world, carrying its own cold atmosphere, possible moons, internal heat, and memory of a star it no longer follows. That is the emotional power of planetary migration. It turns the solar system from a fixed arrangement into a story of movement and loss. The planets we know may have found their places only after another world lost its place completely. This also means the term solar system is more complicated than it sounds. We often define it by what belongs to the Sun now. The planets, dwarf planets, asteroids, comets, and distant objects still held by solar gravity. But in the early history of the Sun, there may have been objects that once belonged and no longer do. A planet could be born around the Sun, shaped by the Sun, and later escape the Sun forever. Does it stop being part of the solar system's story just because it no longer belongs gravitationally? No. It becomes part of the missing history. A world can be absent from the present and still be essential to the past. This is why migration models are so important. They let scientists test possible pasts. They begin with different staffing arrangements, then allow gravity to work. Some simulated solar systems survive, some fail, some lose the wrong planet. Some disturb the inner solar system too much. Some leave Neptune in the wrong place. Some produce a Kuiper belt that does not match what we observe. The goal is not to create a dramatic story. The goal is to find a history that can lead to the solar system we actually see. And sometimes, the path to our solar system seems to pass through chaos. That is unsettling, because it means the calm we depend on may have required a violent transition. Earth's stable orbit, the distant placement of Neptune, the structure of the Kuiper belt, the long-term arrangement of the giant planets, all of it may be connected to a time when the outer solar system was unstable enough to eject a planet. The solar system did not simply become safe by avoiding danger. It may have become safe by passing through danger. This is a common pattern in planetary systems. Early instability can remove unstable bodies, leaving behind a configuration that lasts. The surviving planets are not necessarily the only planets that formed. They are the ones that ended up in long-term stable positions after the chaos. That makes our list of planets feel different. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. 8 survivors, possibly not 8 originals. This idea also makes Uranus and Neptune more mysterious. They are not just cold, distant planets. They may be survivors of a violent rearrangement. Their current positions may be the result of being pushed outward, scattered, stabilized, and spared. If a 5th ice giant once existed, then Uranus and Neptune may be the worlds that remained after the outer solar system chose its final shape through gravity. Chosen is the wrong word, of course. There was no choice, only motion, only mass, only timing, only close encounters that happened in one way instead of another. But from a human perspective, it can feel like survival. A close encounter, a little different. And Neptune might have been ejected, a different timing, and Uranus might have been lost. A slightly different path, and Jupiter might have disturbed the inner solar system more strongly. The system we live in may depend on ancient accidents so delicate that changing them could create a completely different solar system. That is what planetary migration reveals. The present is not inevitable. It is the result of a path through many possible pasts. And in one of those pasts, perhaps the one that became real, a lost ice giant took the path that ended in darkness. The more we think about the giant planets moving, the more the solar system becomes alive with hidden history. Neptune did not merely sit far away. It may have migrated through a disk and sculpted the Kuiper belt. Jupiter did not merely orbit peacefully. It may have helped eject a world. Saturn did not merely carry rings. Its gravitational relationship with Jupiter may have helped trigger instability. Uranus did not merely tilt in silence. It may have been pushed, disturbed, and spared. The outer solar system becomes a crime scene of gravity. But unlike a crime scene on Earth, the evidence is spread across billions of kilometers and billions of years. The witnesses are icy bodies. The fingerprints are orbits. The missing victim may be a planet. This is why the story must move slowly. If we jump directly to the missing planet, we miss the deeper point. A planet can only be thrown out if the system around it becomes unstable enough to allow it. The lost world is not a random accident in an otherwise peaceful system. It is the possible result of an error when the giant planets were rearranging the solar system. First, the giants moved. Then the disk was disturbed. Then the small bodies scattered. Then the orbits changed. Then instability grew. And only then could a planet be lost. This chain of events matters because it turns the lost planet from a strange idea into a consequence. If the giant planets migrated, and if their migration caused instability, and if instability required the removal of one large body, then the missing planet becomes part of a larger gravitational story. It is not just a planet disappeared. It is the solar system became stable by ejecting a planet. That is much more powerful. It means the lost planet may have been involved in shaping the final order of the worlds we know. Its disappearance may have helped leave Jupiter, Saturn, Uranus, and Neptune in their current arrangement. Its absence may be written into the way the outer solar system settled. It may have been the price paid for the calm we see today. And this leads naturally to the next question. If the giant planets were moving, and if their movement created the conditions for ejection, then what exactly was this missing planet? Was it small? Was it massive? Was it like Neptune? Was it closer to Uranus? Could it have had moons? Could it have had rings? Could it have been a true giant world, born in the same ancient disk as the others, only to be removed before the solar system became the system we recognize? To answer that, we have to look more closely at the idea of the missing fifth giant planet, not as a fantasy, but as a possible lost member of the Sun's original family. That is where the idea of the missing fifth giant planet begins. Not with a telescope image, not with a new point of light moving slowly beyond Neptune, not with a direct discovery in the darkness, but with a problem. The solar system we see today has 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. 2 gas giants, 2 ice giants, all moving in long, stable orbits around the Sun. From our modern point of view, this feels complete. It feels like the outer solar system has always had this exact structure. Jupiter first, then Saturn, then Uranus, then Neptune. 4 giants. No more. But if the early solar system went through a period of migration and instability, then 4 may not have been the original number. There may have once been 5, a 5th giant planet, a lost ice giant, a world large enough to matter, but not large enough to survive the chaos. This is not the same idea as Planet 9. Planet 9, if it exists, would be a distant planet still orbiting the Sun today, far beyond Neptune, influencing the orbits of remote icy objects. The missing 5th giant planet is different. It would not be hiding at the edge of the solar system. It would not still belong to the Sun in any ordinary way. If this planet existed and was ejected, then it is no longer waiting to be found in a normal solar orbit. It is gone, not dead, not destroyed, but removed. That difference makes the idea more haunting, because a hidden planet is still part of the family. A thrown-out planet is an exile. The 5th giant planet would probably not have been like Earth. It would not have been a rocky world with continents, oceans, and a thin atmosphere. It would more likely have been an ice giant, perhaps broadly similar to Uranus or Neptune. A cold, massive planet with a deep atmosphere, a heavy interior, ices under immense pressure, and a thick envelope of hydrogen, helium, methane, and other compounds. It may have been blue, or grey, or pale green, or something darker and stranger depending on its atmosphere and the light of the young sun. It may have had moons, it may have had rings, it may have had storms moving through its clouds, it may have had a powerful magnetic field, a deep internal structure, and a slow rotation in the outer dark. A real planet, not a fragment, not a dwarf planet, not a comet, a giant world. And yet, if it existed, it is absent from the solar system today. That absence is what makes the idea feel almost impossible at first. How can an entire giant planet be missing? A small object can be lost. A comet can be thrown away. An asteroid can be shattered. But a planet feels too important to simply vanish from the system. We think of planets as permanent members, as the largest pieces of order around the Sun. But gravity does not respect emotional importance. A planet is only safe if its orbit is stable. If the orbit becomes unstable, even a giant world can be forced out. The missing fifth giant planet may have formed in the same general outer region as Uranus and Neptune, in the cold part of the young solar system where ices and gases could gather. The early disk may have had enough material to build several large planetary cores. Some of those cores captured gas. Some became the ice giants. Some may have competed for space and gravitational stability. The outer solar system may once have been more crowded than it is now. That crowding matters. A stable planetary system needs enough separation between large bodies. If massive planets are too close, their gravity can disturb each other over time. At first, the system may seem stable. Orbits may repeat. Nothing dramatic may happen for thousands or even millions of years. But small gravitational tugs build up. Resonances strengthen. The disk changes. Planets migrate. Eventually, a system that looked stable can become unstable. The fifth giant planet may have been the extra body that made the outer solar system too crowded to last. For a while, it may have orbited the Sun like any other planet. Cold, distant, ancient, moving slowly through the early dark. Then the outer planets began to shift. Jupiter and Saturn changed their relationship. Uranus and Neptune moved. The disk of icy bodies was disturbed, and the fifth planet found itself in a dangerous gravitational game. The key thing to understand is that the lost planet did not need to be weak. It may have been massive by Earth standards. It may have been 10 times Earth's mass, or perhaps similar to Uranus or Neptune in scale. But in a system with Jupiter, mass is relative. Jupiter is so enormous that even another giant planet can become the smaller player in a close gravitational encounter. A world can be huge and still be vulnerable. That is one of the strange lessons of planetary systems. Size protects you only until something larger controls the outcome. If the fifth planet had a mass similar to Uranus or Neptune, it would have been strong enough to affect the orbits of smaller bodies. It could have scattered planetesimals. It could have shaped parts of the outer disk. It could have had moons of its own. But if it crossed paths with Jupiter, it would be entering the territory of a much stronger gravitational power. Jupiter could change its fate. This is why the fifth planet is often imagined as an ice giant rather than another Jupiter. If there had been an extra Jupiter-sized planet, the solar system might have become far more violently unstable. The surviving architecture would be harder to preserve. But an additional ice giant gives the early system another large body to remove without destroying the whole arrangement. It is massive enough to matter, but small enough, compared with Jupiter, to lose. That may be why the idea fits so well emotionally and dynamically. The lost planet was not insignificant, but it was expendable to gravity. That is a cold sentence, but it captures the heart of the hypothesis. The early solar system did not care which planets survived. It did not have a plan to protect Earth, or preserve Neptune, or save the fifth giant. Gravity simply acted. The bodies moved. The unstable arrangement evolved. One world may have been pushed into an orbit that could not last, and once that began, the planet's future narrowed. Imagine the fifth giant planet before the chaos. It orbits somewhere among the early outer planets, perhaps closer to the Sun than Neptune is today, perhaps in a region that would later be cleared and rearranged. Around it, small icy bodies move in countless paths. The young Sun is brighter than any other object in its sky, but still distant compared with the inner planets. Jupiter and Saturn move inward of it, enormous and dangerous. Uranus and Neptune are nearby in the broader gravitational sense. For millions of years, the planet may belong. Then the architecture begins to shift. The fifth planet's orbit is stretched. It passes closer to another ice giant. It is pushed outward, then inward, then outward again. Each encounter changes its path. A planet in this condition is no longer safe. It is no longer moving in a clean, circular path that avoids other worlds. It is crossing gravitational boundaries. It is entering regions where the next encounter could be stronger than the last. It is still a planet, still whole, still massive, still real. But it is becoming dynamically homeless before it is physically removed. That phrase matters. Dynamically homeless. A planet can lose its place before it loses its star. The fifth giant planet may have entered that state during the instability. It still orbited the Sun, but no longer in a stable way. Its orbit may have become elongated. Its closest approach may have brought it into dangerous regions. Its farthest distance may have carried it deep into the outer solar system. It may have passed through the same regions again and again, each time risking another gravitational encounter. This is how a system ejects a planet. Not usually through one clean shove from a calm orbit, but through a sequence of instability. First, the planet is disturbed. Then it begins crossing paths. Then it encounters other giants. Then its orbit becomes more extreme. Then Jupiter, or sometimes another giant in a model, delivers the final change. After that, the planet is no longer bound. The Sun loses it. This possibility makes the fifth giant planet different from every planet we know. The planets that remain became part of the permanent solar system. They settled into long-term orbits. They became names, symbols, targets for spacecraft, objects of mythology and science. The lost planet would have had no such future. It left before humans, before life on land, before the solar system became a familiar map. It became a world without a known sky. If it still exists, it is not warmed by the sun in any meaningful way. It would be drifting between stars, perhaps far beyond anything we can trace back with confidence. Its atmosphere may be frozen or altered. Its internal heat may still slowly leak outward. If it had moons, some may have remained bound, depending on the violence of the ejection. Or it may have lost them during close encounters. It could be alone now, or carrying a small, broken system of its own. No one knows, and that uncertainty is part of the mystery. A missing planet is not only missing in space, it is missing in detail. We do not know its color. We do not know its exact mass. We do not know where it formed. We do not know whether it had moons. We do not know when exactly it left. We do not know where it is now. We do not even know for certain that it existed. But the possibility is enough to change the story. Because if it existed, then the solar system once had a planet that no human culture ever named, a planet that never appeared in ancient skies, a planet that never became a wandering star to early astronomers, a planet that never received a mythological identity. It belonged to the sun before there were eyes on Earth to see the sky. It was part of our system before our story began. Then it left before anyone could remember it. That makes it feel less like a hidden planet and more like a forgotten one. The fifth giant planet may be one of the oldest missing chapters in our cosmic history. And the reason scientists consider it is not emotional. It comes from the difficulty of building the solar system we see today. The outer planets have their current orbits. The Kuiper Belt has its current structure. The inner planets survived. Jupiter and Saturn ended up in a configuration that did not destroy everything. Uranus and Neptune remained. Neptune migrated outward and shaped the icy belt beyond it. A successful model has to explain all of that. When only 4 giant planets are used, the simulations can work in some ways, but they may also run into problems. The instability can become too strong or too weak. Uranus or Neptune can be ejected instead of surviving. Jupiter and Saturn may end up with the wrong orbital relationship. The inner solar system can be disturbed too much. The final system may not match the one we observe closely enough. Adding a 5th giant planet gives the model another possible outcome. The extra planet can take the loss. It can be scattered away while the 4 surviving giants remain. This is why the missing planet is not just an extra object added for drama. It can act like a gravitational buffer. It can absorb part of the chaos that might otherwise harm the planets we still have. It can interact with the outer planets, be pushed inward or outward, and eventually be ejected, leaving behind a more stable system. In other words, the fifth planet may have helped the solar system survive by not surviving as a member of it. That is the disturbing elegance of the idea. The planet's absence becomes part of the system's stability. If it had remained, the outer solar system might have stayed too crowded. If a different planet had been ejected, we might not have Uranus or Neptune. If Jupiter and Saturn had interacted differently, the inner planets might have been more disturbed. But in the history that may have happened, the fifth giant planet became the world that left. This does not mean the solar system was lucky in a conscious way. But from our perspective, it feels like luck. Because we are here only in the version of history where Earth survived. There may have been many possible early solar systems that did not lead to a stable Earth. Some may have sent too many comets inward. Some may have disturbed the terrestrial planets. Some may have lost Neptune. Some may have created a different outer architecture entirely. We cannot observe those lost possibilities. We live inside the one outcome that remained. And perhaps that outcome required losing a planet. The missing fifth giant planet also changes the way we think about the word planet. A planet feels like a permanent title. Once a world becomes large and round and orbits a star, we imagine it as part of a stable family. But a planet is not guaranteed a permanent home. It can be born around a star and later become unbound. It can stop being a planet of that star and become a free-floating world. It can carry its planet nature with it while losing its planetary address. That is a strange idea. A planet can remain a planet and lose its solar system. The fifth giant, if it existed, would be exactly that, a planet without its original context. It may still have mass, gravity, atmosphere, internal layers, and perhaps moons. But it no longer has the sun as its central light. It no longer shares the rhythm of the other planets. It no longer belongs to the map children learn when they memorize the solar system. It is not counted because it is not here. But if it helped shape what is here, should it feel completely separate from the story? That question has no simple answer. Scientifically, if it is no longer bound to the sun, it is not a current planet of the solar system. But historically, it may still be a former planet of the solar system. A lost member, a world whose existence could explain why the remaining members stand where they do. This is why the idea feels so cinematic. It gives the solar system a ghost. Not a supernatural ghost, a gravitational ghost. Something absent that still explains the shape of what remains. In astronomy, this happens often. We infer unseen things from their effects. Neptune itself was discovered because Uranus did not move exactly as expected. Dark matter is inferred from gravity. Black holes can be detected through the motion of stars and gas. Invisible objects can become real to science through the way they shape visible things. The fifth giant planet, if it existed, is harder because its direct effects are ancient and mixed with many other events. But the principle is similar. Sometimes, what is missing can be studied through what it changed. The lost planet may be one of those invisible causes. Its trace may not be a clean wobble in one orbit, but a whole arrangement of outcomes. The survival of Uranus and Neptune, the migration of Neptune, the shape of the Kuiper Belt, the final positions of the giant planets, the stability of the inner solar system, the absence itself. Of course, there are other possibilities. Scientists may refine the models. New observations may change the picture. The early solar system may have found a way to reach its current state without a fifth giant. The missing planet may turn out to be unnecessary or different from what we imagine. That is how science works. A strong hypothesis is not a final answer, It is a candidate that must survive evidence. But even as a candidate, the fifth giant planet is powerful because it reminds us that the solar system is not only what we can see, it is also what may have been removed. This idea becomes even more important when we compare the lost planet to the planets that remain. Jupiter survived because it was massive enough to dominate. Saturn survived, perhaps because its orbit and timing allowed it to settle. Uranus and Neptune survived, though they may have been shaken and moved. The fifth giant, if it existed, did not survive the system's final architecture. It was not necessarily smaller than Earth. It was not necessarily fragile. It was not necessarily doomed from the beginning. It simply ended up on the wrong path at the wrong time. In planetary systems, timing can decide destiny. A close encounter slightly earlier or later could change everything. A resonance crossing at a different moment could protect one planet and endanger another. A disk with slightly more or less mass could alter migration. A passing object, a scattering event, a sequence of small gravitational exchanges could lead to a different final system. The lost planet may be the result of this delicate chain, and that makes its story feel tragic in a cosmic way. Not tragic because a planet suffered consciously, but tragic because a whole world may have existed only to be removed before it could ever become part of the sky of life. It may have been born around the sun. It may have circled the young star for millions of years. It may have had moons moving around it. It may have helped scatter icy bodies and shape the outer disk. Then, a sequence of gravitational encounters pushed it farther from stability. And finally, one encounter launched it away. After that, the sun became just another distant star. This is the emotional core of the missing fifth giant planet. It is not just missing. It was once home. At least, home in the gravitational sense. The sun held it. The young solar system shaped it. The other planets influenced it. Then the system rejected it, not by intention, but by dynamics. This is why the word "thrown out" feels so strong. It makes the event sound violent, and in gravitational terms, it was. A planet that had formed around the Sunday may have been accelerated away until it no longer belonged. The solar system did not gently release it. It lost it through instability. But again, we have to be careful. This is a possible story, a serious hypothesis, not a confirmed chapter. The evidence is indirect. The models are complex, and the early solar system is difficult to reconstruct. We may never know with absolute certainty whether the fifth giant existed, but the idea remains. One of the most fascinating possibilities in planetary science because it explains absence through survival. The planets we see may be the winners of a gravitational selection. The fifth giant may be the world that lost. And if it lost, the next question becomes unavoidable. How could even a giant planet be forced out of the solar system completely? What kind of gravitational encounter could take a world born around the sun and send it into interstellar space? What planet had enough power to do that? The answer points toward the largest planet we have, the one that dominates the outer solar system, the one whose gravity has shaped comets, asteroids, moons, and perhaps the fate of an entire missing world. Jupiter. Because if the fifth giant planet was the lost member of the Sun's family, Jupiter may have been the one that threw it into darkness. To understand how that could happen, we have to understand Jupiter differently, not as a beautiful striped planet, not as a world with storms, moons, and a great red spot, but as the strongest gravitational weapon in the solar system. Jupiter is not just the largest planet. It is the planet that dominates the space around it more than any other world does. It contains more mass than all the other planets combined. Its gravity shapes the asteroid belt. It captures and releases comets. It holds dozens of moons. It bends the paths of objects that come too close. It can protect, disturb, trap, redirect, or destroy, depending on the encounter. From far away, Jupiter may look calm, but gravitationally, it is not calm at all. It is a giant moving through space with enough mass to rewrite orbits. This is why Jupiter becomes so important in the story of a lost planet. If an extra ice giant once existed, and if that planet was pushed into an unstable orbit, then it would eventually need a final encounter strong enough to remove it from the Sun's control. Uranus and Neptune could disturb it. Saturn could change its path. But Jupiter had the power to finish the job. Jupiter could give a planet the one thing it needed to escape: energy. In orbital mechanics, being thrown out does not mean being pushed away in a straight line like a ball. A planet is not sitting still, waiting for something to shove it. It is already moving around the Sun. Its future depends on speed, direction, and distance. If its orbit is bound, it will keep returning. If it receives enough energy, the orbit stretches. If it receives too much, the orbit never closes again. That is, escape. A planet escapes the solar system when it is moving fast enough that the Sun cannot pull it back into an orbit. Jupiter can help make that happen. Not through rockets, not through impact, through gravity. Gravity is invisible, but it can exchange motion between objects. When a smaller object passes near a larger planet, its path bends. Depending on the geometry of the encounter, it can leave with more speed relative to the Sun or less speed. Spacecraft use this deliberately. A probe can fly by Jupiter or another planet and gain speed, stealing a tiny amount of orbital energy from the planet. The planet barely changes because it is so massive. But the spacecraft can change dramatically. A planet can experience the same principle, only on a much greater scale. If a smaller ice giant passed close enough to Jupiter during the chaos of the early solar system, Jupiter's gravity could alter its path violently. The two worlds would not need to touch. They would not need to collide. The encounter could happen across hundreds of thousands or millions of kilometers, depending on the details, and still change the smaller planet's orbit forever. That is the strange power of gravity. It acts without contact. A close gravitational encounter is like a silent collision in motion. The bodies miss each other physically, but their orbits do not leave unchanged. For the lost planet, such an encounter could have been the final step in a longer chain of instability. Before meeting Jupiter, it may already have been in trouble. Its orbit may have been stretched by interactions with Saturn, Uranus, Neptune, or the disk of icy bodies. It may have crossed dangerous regions again and again. It may have been moving inward and outward through paths no stable planet could keep forever. Then, Jupiter enters the story. A close approach, a gravitational swing, a sudden change in orbital energy. And after that, the lost planet may no longer have been on a closed path around the Sun. This is difficult to picture because nothing in daily life moves this way. On Earth, throwing something means pushing it with a hand, a machine, or an explosion. But in space, throwing can mean arranging motion so that gravity does the work. Jupiter does not need to grab the planet. It simply bends the planet's path at the right time, in the right direction, with enough power. The lost planet comes in as a member of the solar system. It leaves as an exile. Jupiter itself would barely appear changed. That is another unsettling part of the story. The smaller giant planet could lose everything: its orbit, its place, its connection to the Sun. Jupiter, because of its enormous mass, would continue almost as before. It may shift slightly. It may exchange a little energy. But compared with the lost planet, Jupiter remains the dominant survivor. In a gravitational encounter, mass is authority. Jupiter had authority. This does not mean Jupiter was malicious. There is no intention in gravity. Jupiter did not decide to exile another world. It did not protect Earth knowingly. It did not choose a victim. It simply moved according to physics. The lost planet moved according to physics. Their paths crossed at the wrong time. Gravity did the rest. That is what makes the event feel so cold. A whole planet can be lost without anything choosing to lose it. Only timing, only mass, only motion, only the geometry of a close encounter. If the fifth giant planet existed, its final meeting with Jupiter may have lasted only a short time compared with the age of the solar system. The decisive part of the interaction could have been brief, perhaps just one dramatic gravitational swing in an era of chaos. But its effect would last forever. One encounter could change a planet's path from returning to never returning. That is the terrifying efficiency of Jupiter. It can turn temporary instability into permanent exile. To see why, imagine the lost planet approaching Jupiter on a stretched orbit. It has already been disturbed. It is moving through the outer solar system in a dangerous path. Jupiter is orbiting the Sun, carrying its enormous gravitational field with it. The lost planet enters Jupiter's region of influence, not close enough to collide, but close enough to be strongly bent. As it falls toward Jupiter, it gains speed. As it swings around, its direction changes. As it leaves, its path relative to the Sun has been rewritten. If the geometry is right, the planet steals orbital energy from Jupiter's motion around the Sun. Jupiter loses an almost unnoticeable amount. The smaller giant gains enough to climb farther away from the Sun than before. If the gain is large enough, the planet is no longer bound. The Sun's gravity still pulls on it. But not enough. The planet moves outward. Jupiter falls behind. The orbit does not close. The planet has been ejected. This is not science fiction. This kind of gravitational exchange is a real part of orbital dynamics. The question is not whether gravity can eject objects. It can. The question is whether the early solar system created the right conditions for a giant planet to be ejected this way. That is where the models matter. And in some models, Jupiter becomes the most likely final ejector. Because Jupiter is the heavyweight. Saturn is massive, but Jupiter is stronger. Uranus and Neptune are giant worlds, but much smaller than Jupiter. If an ice giant needed to be removed from the system, Jupiter is the planet most capable of doing it. This is why Jupiter is sometimes described as a protector of Earth, because its gravity can redirect or capture some objects that might otherwise threaten the inner planets. But that description is too simple. Jupiter is not only a protector, it is also a disturber. It can send objects inward as well as outward. It can shape danger as well as reduce it. Its gravity is not morally good or bad. It is powerful. Power creates consequences. In the early solar system, those consequences may have been enormous. Jupiter may have scattered comets. It may have shaped the asteroid belt. It may have influenced the delivery of water and volatile materials. It may have helped trigger or survive giant planet migration. And perhaps, in one of the most dramatic possibilities, it may have thrown an entire planet away. If that happened, the event would have changed Jupiter too, but only slightly. Jupiter's orbit may have shifted. Its relationship with Saturn may have evolved. The system's energy would have been redistributed. But Jupiter would remain. It would continue circling the Sun, massive and dominant, while the lost planet began a one-way journey outward. This creates a strange image. Jupiter, still shining in the solar system today, may be the last planet that ever had a close relationship with the lost giant. Not in a gentle way, in a violent gravitational way. The final planet the lost world encountered before becoming free. If the lost planet had moons, they may have been affected too. A close encounter with Jupiter would be dangerous for any moons around the escaping planet. Some might remain bound if they were close enough to the planet and the encounter was not too disruptive. Others could be stripped away. Some could be thrown into their own separate paths. Some could collide, be captured, or be lost into solar orbit before later being scattered. We do not know, but the possibility is haunting. A planet might not have escaped alone. It could have carried moons with it. Or it could have lost them during the same violence that removed it from the solar system. Imagine being a moon of that planet during the instability. For millions of years, you orbit a giant world, while the sun rises and sets as a distant star. Then, the planet's path becomes unstable. Other giant planets loom larger during close encounters. Jupiter passes in the sky not as a familiar distant object, but as an overwhelming gravitational presence. Then the entire system is flung outward or torn apart, depending on the violence of the meeting. A lost planet could mean lost moons too, lost skies, lost tides, lost histories that never had observers. This is the kind of scale Jupiter was capable of shaping. And it may have done so before the solar system became quiet enough for worlds like Earth to develop long-term stability. The timing matters. If this giant instability happened early enough, then Earth may have still been young. The inner planets may have been forming, cooling, or recovering from major impacts. The solar system may still have contained far more debris than it does today. A violent rearrangement of the giant planets could have sent waves of small bodies through the system, potentially affecting the impact history of many worlds. This is why the lost planet story is not isolated. It connects Jupiter to everything. A close encounter in the outer solar system can change the outer planets. Changing the outer planets can disturb small body populations. Disturbed small bodies can travel inward. Inward objects can strike planets and moons. Impacts can change surfaces, atmospheres, and histories. The outer solar system may seem remote, but its gravity can reach into the fate of inner worlds. This is one of the hidden truths of planetary systems. No planet is completely alone. Even worlds separated by billions of kilometers belong to the same gravitational architecture. Jupiter does not need to touch Earth to matter to Earth. Neptune does not need to visit the inner solar system to shape objects that later do. The lost fifth planet, if it existed, did not need to come near Earth to become part of Earth's larger history. The solar system is one connected machine of gravity, and Jupiter is its largest moving part. That is why Jupiter's role in this story feels almost mythological, even though it is pure physics. In ancient mythology, Jupiter was king of the gods. In the solar system, Jupiter is not a god, but its gravitational role is king-like. It dominates. It commands the movements of smaller bodies. It changes the fate of comets. It holds a system of moons like a miniature solar system. And perhaps, long ago, it decided the fate of a planet by being massive enough to change its path forever. Again, not by choice, but by existence. Sometimes being massive is enough to become destiny for everything nearby. This also explains why the lost planet could not simply return. Once ejected, the planet would no longer be on a long but closed orbit. Many distant objects return because they remain bound to the sun. A comet in a long orbit may travel far into darkness and eventually fall back inward. But an ejected planet is different. Its trajectory is open. The sun's gravity may slow it, but not enough to reverse it. The planet would continue outward, past the realm of the known planets, past the distant scattered objects, past the region where the sun is clearly dominant. Eventually, it would join the population of free-floating planetary bodies moving through the galaxy. At that point, calling it a solar system planet becomes complicated. Physically, it may still be the same world. It may still carry the chemistry of its formation. It may still preserve clues of the sun's early disk. But gravitationally, it is no longer ours. It belongs to the Milky Way more than it belongs to the sun. That is what Jupiter may have done. It may have changed the lost planet's address from the solar system to interstellar space. This is a deeper kind of loss than destruction. If a planet is destroyed, its fragments may remain. They may orbit the sun. They may become a belt, a family of debris, a record of impact. But if a planet is ejected whole, the solar system loses almost everything. No surface to study, no orbit to track, no fragments necessarily left behind in obvious form, only the gravitational aftermath. A whole world gone intact. That is more mysterious than rubble. Because rubble can be found, an escaped world may be forever beyond identification. Even if astronomers someday detect a rogue planet drifting through the galaxy, how would we know it came from our solar system? It may have moved for billions of years. The sun itself orbits the center of the Milky Way. Other stars pass and move. The lost planet's path would be difficult to reconstruct after such enormous time. The galaxy mixes its wanderers. The lost planet may still exist, but no longer carry an obvious tag saying where it came from. It could pass through interstellar darkness as one of many rogue worlds, a former child of the sun hidden among the galaxy's orphans. This makes Jupiter's possible role feel even more final. It did not merely move the planet to a distant orbit. It may have erased our ability to ever find it as ours. The ejection would have taken a world from a known system and released it into a galaxy where identity becomes almost impossible to trace. That is why the fifth planet, if real, is not like the planets we hope to discover beyond Neptune. It is not an object waiting patiently in the dark for better telescopes. It is a lost history event. The evidence is not the planet itself, but the way the surviving solar system behaves. Jupiter's weapon was not a laser, an explosion, or a collision. It was the quiet, invisible transfer of orbital energy, and that may be more powerful than any dramatic image. Because in space, the greatest violence is often silent. No sound, no fireball, no shockwave traveling through air. Just two massive bodies passing close enough for gravity to change the future. The planet leaves on a new path. Jupiter continues around the sun. The solar system eventually calms. Billions of years later, tiny beings on Earth look at the planets and wonder why the arrangement seems to work best if one world is missing. This is the kind of mystery that only time can hide. The event, if it happened, would be over in the ancient past. The lost planet would be far away now. Jupiter would show no obvious confession. Its storms would continue. Its moons would orbit. Its clouds would turn. Its role as possible ejector would be written not on its surface, but in the history of the whole system. We see Jupiter in the night sky as a bright point, but that point may have once changed the fate of a world. It may have been the last gate the lost planet passed before leaving the sun forever. This changes the emotional meaning of Jupiter. It becomes not only a giant planet to admire, but a reminder that the solar system's beauty is built on power. The same gravity that holds moons and shapes orbits can also exile worlds. The same mass that makes Jupiter majestic makes it dangerous. The same planet that helps define the solar system may have helped decide what the solar system would lose. Jupiter is both architect and executioner, if this story is true. That does not make Jupiter evil. It makes Jupiter important. The lost planet hypothesis depends on many steps, and Jupiter is one of the most important. Without a powerful ejector, the fifth giant might not leave. Without the fifth giant leaving, the surviving system might not settle the same way. Without that settling, the outer planets might look different. The Kuiper Belt might look different. The inner solar system might have experienced a different history. One gravitational encounter can echo for billions of years. This is why the idea of Jupiter throwing out a planet feels so dramatic. It is not just a single event. It is a branching point. Before the encounter, There are multiple possible solar systems. After the encounter, one path becomes real. 4 giants remain. 1 giant leaves. The system begins moving toward the stable architecture we see today. The solar system we know may have been shaped by a moment when Jupiter gave another planet too much speed to stay. That speed is the key. Not a push, not a blast, not a collision. Speed. A change in motion, enough energy to turn an orbit into an escape path. Once that happened, the lost planet's story would become very different from the stories of the planets that remained. It would no longer share their years. It would no longer return to the same places. It would no longer be part of the rhythm of the sun. It would move outward into colder and darker space, carrying with it whatever atmosphere, moons, heat, and scars it still had. At first, the sun would still be the brightest star in its sky, then just a bright star, then an ordinary one, then one light among many in the Milky Way. The planet would not stop being real, but it would stop being ours. That is the consequence of Jupiter's gravitational weapon. It does not have to destroy a world to remove it from history. It only has to make the world leave. And once we understand how Jupiter could do that, the next part of the story becomes unavoidable. What would it actually be like for the planet after escape? Where would it go? Would it freeze completely? Could it keep moons? Could it still hold internal heat? Would it become invisible forever? If Jupiter was the planet that opened the door, then the Lost World's next chapter begins beyond that door. Away from the sun, away from the planets, away from the solar system entirely, into interstellar darkness. That is where the lost planet's story would truly begin. Not at the moment Jupiter changed its path, not even at the moment its orbit became unstable, but when the planet crossed the invisible boundary between being held by the sun and no longer belonging to it. This would not happen like a door opening. There would be no wall around the solar system, no bright line in space, no sudden moment where the sun disappears. Instead, the escape would be gradual. The planet would move outward on a path that no longer closes. At first, it would still feel like part of the solar system. The sun would still be the brightest object in its sky. Jupiter, Saturn, Uranus, and Neptune would still be behind it somewhere, shrinking with distance. The planet would still carry the memory of the system that formed it. But its future would have changed. It would not come back. That is what makes an ejected planet different from a distant planet. A distant planet can still be bound to the sun. It can move far away and return along a long orbit. Comets do this. Some small objects may travel into the deep outer regions and still remain part of the sun's family. But an ejected planet has crossed into a different kind of path. The sun can slow it. The sun can still pull on it. But the sun cannot turn it around. The planet has become unbound. At first, the change might not look dramatic from the planet itself. The sun would not vanish instantly. It would only grow smaller with time. The young solar system would recede behind it. The giant planets would fade. The light would weaken. The warmth of the sun, already faint for a distant ice giant, would become almost meaningless. The lost planet would enter a long twilight, a twilight that lasts not for hours, but for ages. If it had once orbited in the outer solar system, it was already cold. It may have never known warmth in the way Earth does, but being ejected would make that coldness deeper. It would no longer have even the weak regular rhythm of a solar orbit. There would be no year in the ordinary sense, no return to a closest approach, no seasonal relationship with the sun, only movement away. The sun would become a star behind it, then one star among many, and eventually just another point in the Milky Way. That may be the loneliest part of the escape. A planet is normally defined by what it orbits. Earth is Earth partly because it orbits the sun. Jupiter is Jupiter partly because it belongs to the solar system. Even Neptune, far away and cold, still follows the sun. Its year is long, but it is still a year. Its motion is still part of the same gravitational family. The lost planet would lose that family. It would not stop being a planet in a physical sense. It would still have mass, gravity, layers, perhaps an atmosphere, perhaps moons, perhaps internal heat, but its identity would change. It would no longer be a planet of the sun. It would become a free-floating world, moving through the galaxy without a star. A rogue planet. A world between stars. That phrase can sound adventurous, but the reality would be almost impossibly bleak. No sunrise, no sunset, no nearby star growing larger in the sky. No warm orbit, no home system, only darkness, interrupted by distant stars. If the planet were an ice giant, its outer atmosphere would become extremely cold. Sunlight would no longer provide meaningful energy. Any warmth would have to come from inside the planet itself, leftover heat from formation, slow gravitational settling, radioactive decay in deeper material, or other internal processes. The planet would not be warmed from outside. It would fade into its own internal life, if it had any. Its upper layers might change. Clouds could freeze. Chemistry could slow. Atmospheric patterns might weaken or transform. The bright colors it may have had under the young sun could become harder to see because there would be almost no light to reveal them. A world can have storms and clouds, but without nearby light, they become hidden. The planet might still be active in some way, but the galaxy would not easily see it. This is one reason a lost planet could be almost impossible to find. Planets do not shine like stars. They mostly reflect light. Far from a star, there is very little light to reflect. A rogue ice giant in interstellar space would be dark, cold, and faint. It might emit a little infrared radiation from internal heat, but detecting it across enormous distances would be extremely difficult. Unless it passed near a star, or unless a telescope caught its faint heat, it could drift unseen for billions of years. A whole planet could be out there and almost invisible. That is one of the strangest ideas in astronomy. Not invisible because it is small, invisible because it is cold and alone. If the lost planet had moons, their fate would depend on the violence of the ejection. Some moons might have been stripped away during close encounters with other giant planets, especially Jupiter. A moon that orbited far from the planet could be pulled loose. Another might be thrown into an independent path. Some could collide, break apart, or be captured temporarily by other bodies. But moons close to the planet might survive. They would follow the planet into exile. Imagine that. Not just one lost world, but a small lost system. A giant planet and a few moons all traveling together through interstellar space, no longer orbiting the sun, no longer part of the map we know. The moons would still orbit the planet, because their closest gravitational master would remain the same. The planet would carry them into the dark, like a broken piece of the solar system, drifting away intact. From the surface of one of those moons, if it had a surface, the sky would be almost impossible to imagine. The giant planet would dominate the view. The sun would be only a distant star. The familiar planets would be gone. The Milky Way would stretch across the sky, but not as a home galaxy seen from a planet around a star. It would be the background of exile. There would be no day, only the faint light of stars. If the moon had ice, it would freeze harder. If it had an ocean beneath its surface, internal heat and tidal forces might decide whether it survived. If the planet kept several moons, their gravitational pulls could create tides. Tidal heating can warm moons from within, as we see in our own solar system. That does not mean a lost planet's moons would be habitable, but it means the story is not simply everything freezes and ends. Some heat can come from gravity, some energy can come from within. Some worlds can hide activity under darkness. This matters because a rogue planet is not automatically a dead rock. A large planet can retain internal heat for a long time. A thick atmosphere can trap heat. A subsurface ocean, if one existed on a moon or planet, could remain insulated beneath ice. Chemistry can continue in hidden places. The surface may be frozen and black, but the interior could be more complex. The lost planet may be dark, but not necessarily simple. Still, for anything like human life, it would be unreachable and useless. No nearby sunlight, no easy landing, no known position, no path back, no way to identify it as ours unless we somehow traced its motion and chemistry with extraordinary precision. It would be a former member of the solar system, but it would no longer be part of our practical universe. That is the tragedy of ejection. The planet may still exist, but it has been removed from relationship. It no longer helps shape the planets directly. It no longer appears in the sun's sky. It no longer shares the rhythm of the system. It is real, but separated. And separation is one of the great themes of space. The lost planet would not be alone in the galaxy, at least not in the literal sense. The Milky Way contains stars, gas, dust, dark matter, and likely many planets. There may be other rogue planets too. Some may have formed alone. Some may have been ejected from other systems. Some may drift silently between stars, invisible unless they pass in front of a background star or emit faint heat. The galaxy may be full of orphan worlds, but full does not mean close. A rogue planet can drift for ages without coming near another planet. It may pass through interstellar space, with enormous distances in every direction. Stars may be visible in the sky, but none close enough to warm it. The galaxy may contain many lights, but the planet itself would live between them. That is why the phrase rogue planet is so haunting. It suggests motion without home, a planet that still exists but no longer belongs. If the lost planet escaped early in solar system history, it has had billions of years to travel. The Sun itself has moved around the center of the Milky Way many times since then. Nearby stars have changed. Stellar neighborhoods have shifted. The planet's original path would have been stretched, altered, and mixed into the galaxy's motion. Tracing it today would be extraordinarily difficult. Even if we found a rogue ice giant tomorrow, proving it came from our solar system would be almost impossible. The evidence would have to be subtle. Its composition might need to match expectations from the Sun's protoplanetary disk. Its motion might need to be reconstructed backward. Its age might need to fit. Its chemistry might need to tell a story. But after billions of years in the galaxy, the lost planet may have become just one dark wanderer among countless others, a former member of the Sun's family with no visible passport. This makes the loss feel even more complete. The solar system may have not only lost the planet, it may have lost the ability to prove the planet's identity directly. That is why the evidence has to come from the system left behind. The orbits of surviving planets, the Kuiper Belt, the scattered small bodies, the success or failure of simulations, the architecture of the outer solar system. The lost planet's present location may be unknowable, but its ancient absence may still be written into the structure it helped leave behind. In a way, the planet's escape split its story in two. One story continued here, in the solar system. The other continued out there, in interstellar darkness. Here, the remaining planets settled. The outer solar system evolved. Earth changed. Life emerged. Moons were cratered. Comets moved. Humans eventually looked up and began naming the worlds that stayed. Out there, the lost planet drifted. No names, no observers, no sunrise, no maps, only the long, cold movement through the galaxy. If the planet could have seen the sun shrinking behind it, the change would have been slow. At first, the sun would still be bright compared with other stars. Then, less bright, then ordinary. The planet would move so far away that the sun would no longer feel like a parent star. It would simply be one point among the billions in the Milky Way. That transformation is almost impossible to feel from Earth. For us, the sun is everything. It is day, it is heat, it is time. It is the reason weather exists. It is the reason plants grow. It is the central fire of the system. But for the lost planet, the sun would become a memory made of light, a star left behind. That may be the deepest emotional meaning of ejection. The planet does not just leave a place. It loses its center. Every planet in the solar system has a center to its motion, the sun. Even if the orbit is long, tilted, eccentric, or distant, the sun is the anchor. The lost planet would no longer have that anchor. Its motion would be governed by the gravity of the galaxy as a whole, with distant stars and massive structures influencing it over time. Instead of belonging to one star, it would belong to the Milky Way. A planet of the galaxy, not a planet of the sun. That sounds grand, but it is also lonely. The galaxy is not a home in the same way a star system is. A galaxy does not provide a local day, a local year, or a nearby source of warmth. It is a vast gravitational city of stars, but a rogue planet moves through the spaces between its lights. It belongs to the whole structure, but not to any warm neighborhood. This is the difference between being inside a family and being inside a crowd. The solar system is a family of worlds. The galaxy is a crowd of stars. The lost planet would move through the crowd without returning to the family. If it had an atmosphere, that atmosphere might become strange in the deep cold. Depending on the planet's size, composition, and internal heat, some gases might remain. Others might freeze out. Clouds could settle into layers unlike anything we see near the sun. The planet might glow faintly in infrared if it still retained heat. Deep inside, pressures would remain immense. The core and mantle, if those words even fit such a world, would continue evolving slowly. But from outside, it would be almost black, a dark giant moving through darker space. It might pass near stars occasionally, but near, in interstellar terms, can still mean enormous distance. A passing star could slightly alter its path over time. Rare close encounters might change its speed or direction, but most of its existence would be quiet drift. No collisions, no dramatic arrivals, no easy capture into a new system. A rogue planet could wander for billions of years and never find another star to orbit. Could it ever be captured by another star? In principle, capture is possible under the right conditions, but it is difficult. A lone star passing a lone planet usually cannot easily capture it permanently without some way to remove energy from the planet's motion. More complex encounters, such as passing through a dense star-forming region or interacting with multiple bodies, could make capture more plausible. But for a rogue planet, drifting through the galaxy, permanent capture by a new star would not be something to count on. Most likely it keeps drifting. The lost planet may never join another system. It may never again have a star. That makes its escape almost final. Not final because it is destroyed. Final because return is unlikely. This is why the title of this story carries so much weight. A planet thrown out of the solar system is not just moved farther away. It is changed into a different kind of object. It stops being part of the sun's architecture and becomes a free-floating relic. It may still carry the chemistry of its birthplace, but not its gravitational belonging. The solar system loses a planet. The galaxy gains a wanderer. And that wanderer may be older than almost everything familiar on Earth. If it was ejected early, it left before complex life, before animals, before forests, before humans. It may have left while Earth was still young and violent. It may have drifted through the galaxy while continents formed, oceans changed, life evolved, dinosaurs rose and fell, mammals spread, and human beings finally appeared under the same sun it had left behind. All of human history happened after its exile. From the planet's point of view, if it had no observers, nothing was recorded. But from ours, the thought is astonishing. A giant world could have been traveling through the darkness for billions of years, while the solar system slowly became the quiet, familiar place we know. The lost planet may have been gone for almost the entire story of life on Earth. And yet, it may have helped shape the conditions before it left. That is the strange paradox. The planet may be absent from our sky, but present in our history. Its ejection may have helped the remaining giant planets settle. Its removal may have allowed the outer solar system to become stable. Its loss may have been part of the path that led to the arrangement we see today. The planet left, but the consequences stayed. That makes it unlike a normal discovery story. Usually, when we search for a planet, we hope to find the object itself. We want an image, an orbit, a mass, a name. But this lost planet may be a world we understand mostly through absence. Its current journey may be unknowable. Its present sky may never be seen. Its moons, if any survived, may never be counted. Its atmosphere may never be measured. But the possibility of its escape still changes how we see the solar system. It tells us the solar system has a before and after. Before ejection, the outer system may have been crowded, unstable, and dangerous. After ejection, the surviving planets could settle into the architecture we inherited. The thrown-out planet becomes a boundary between chaos and calm. This does not mean everything became peaceful immediately. The solar system continued evolving. Impacts continued. Small bodies continued moving. Planets and moons continued changing. But the removal of an unstable giant could have been one of the decisive steps toward long-term order. The lost planet may have been the price of that order. That phrase sounds dramatic, but it captures the idea. A system with too many large bodies cannot always keep them all. Gravity chooses no favorites. Some bodies remain, some are swallowed. Some collide, some are scattered, some escape. The fifth giant planet, if it existed, may have been the one that escaped. And once it escaped, it entered a state that is almost difficult to call a life, even for a planet. No star-centered year, no familiar family of planets, no system of shared history, except the one it carried away. It would become an ancient cold body, moving through a galaxy that does not know where it came from. This is what makes rogue planets so mysterious. They may be common, but they are hard to understand individually. Without a parent star, they are difficult to detect. Without a known system, their origins are uncertain. Without sunlight, their surfaces or atmospheres are hidden in darkness. They are planets without context, and context is what gives planets stories. Mars has a story because it belongs near Earth and the Sun. Jupiter has a story because it shapes the solar system. Neptune has a story because it marks the outer planetary frontier. A rogue planet has a harder story to tell because it carries its context invisibly. The lost fifth giant would carry the solar system inside it only as chemistry, motion, and ancient history. If it still has moons, those moons may be the only companions that know its past, though they know nothing consciously. If it lost its moons, then it is even more alone. It may pass through interstellar darkness with only its own gravity and internal heat. A silent world moving through the Milky Way since before Earth became alive in any complex way. Could it ever pass near us again? Almost certainly not in any meaningful way, if it was truly ejected. The galaxy is too large, the paths too complex, the timescales too long. It would not loop back like a comet. It would not return to announce its story. Its escape is not a long vacation from the sun. It is a departure. That is why the word escaped has two meanings. The planet escaped the sun's gravity, but it also escaped our ability to know it directly. It became free and lost, both at the same time. This dual meaning is what makes the 6th chapter of the story so haunting. The planet that was thrown out did not simply vanish. It became something else. It crossed from a solar existence to a galactic existence. It stopped being one of the sun's planets and became a dark traveler between stars. And if we could somehow see it now, it might not look dramatic at first. No blazing tail, no glowing atmosphere, no bright surface. Just a cold, giant world, dim in infrared, black in visible light, turning slowly in the dark. But knowing what it was would change everything. It would be a fossil of the solar system's beginning, a world from our own origin story. A planet that may have once moved among Jupiter, Saturn, Uranus, and Neptune. A planet that may have been part of the architecture before the architecture became stable. A planet that may have been removed so the system we know could remain. That is why the idea matters. Not because we can easily find the lost planet, but because imagining its escape reveals how violent planetary systems can be. It shows that planets are not guaranteed permanent homes. It shows that the solar system's calm may be a late chapter after ancient instability. It shows that what is missing can be as important as what remains. The lost planet, if it exists, is now somewhere in the darkness, but its story still points back toward the sun, back toward Jupiter, back toward the era when the giant planets moved, back toward the moment when one world crossed from belonging to exile. And after understanding that escape, the next question becomes even more unsettling. If that planet is still out there, what might it be like now? Could it still have moons? Could it still hold heat? Could it have hidden oceans under layers of frozen material? Could a planet without a star still be more than just a dead frozen rock? To answer that, we have to follow the lost world deeper into the dark. Not just to where it went, but to what it may have become. That question is harder than it first appears, because an ejected planet does not simply become a rock in the dark. If the lost planet was truly a giant world, perhaps similar in nature to Uranus or Neptune, then it would have carried an entire deep structure with it into exile. It would not have been a small frozen stone. It would have been a massive planet, with gravity strong enough to hold thick layers of gas and ice, pressure deep enough to create strange interiors, and enough internal heat to remain more than a dead object for a very long time. The sun would no longer define it, but the planet itself would still exist. That is the first thing to understand. Being thrown out of the solar system does not make a planet disappear. It removes the planet from the sun's family, but it does not erase its mass. It does not erase its gravity. It does not erase the heat trapped inside it. It does not erase its possible moons, its deep atmosphere, or the chemistry locked beneath its clouds. The planet becomes dark, cold, and almost impossible to find, but it does not become nothing. It becomes a rogue planet, a world without a star, and that is one of the strangest kinds of object in the universe. A rogue planet is not orbiting a star in the ordinary way. It moves through the galaxy on its own path, shaped by the gravity of the Milky Way and by distant encounters with stars and other massive objects. It may have been born around a star and ejected, or it may have formed in another way, but the result is the same. A planet-sized body moving through interstellar space without the warmth, rhythm, or identity of a solar system. If our solar system lost a giant planet, then that planet would now be one of these wanderers, somewhere in the Milky Way, not waiting beyond Neptune, not hiding just outside the Kuiper Belt, not circling the sun in a huge orbit, but traveling independently through interstellar darkness. That makes the question, where is it now, almost impossible to answer. If the planet was ejected billions of years ago, it has had almost the entire history of life on Earth to drift. During that time, the Sun itself has moved around the center of the Milky Way. Nearby stars have changed. Stellar neighborhoods have shifted. The galaxy has carried everything forward in its slow rotation. The lost planet would not simply sit in a straight line away from the Sun, waiting to be found. Its path would be part of the galaxy's motion. After billions of years, the original geometry may be almost impossible to reconstruct. The planet may have been moving at only a modest speed by galactic standards, but time is enormous. Even a slow escape becomes vast when multiplied by billions of years. The lost world could now be far from the Sun, perhaps separated by distances so large that it no longer has any obvious connection to its birthplace. It may still be in the Milky Way. Almost certainly, if the ejection speed was only enough to escape the Sun and not the entire galaxy. But the Milky Way is enormous. Being still in the galaxy does not make it close. It could be in some dark region between stars, moving silently through a stellar neighborhood the Sun left long ago. It could have passed near other stars without being captured. It could have traveled above or below the galactic disk. It could be drifting through a region where the Sun is just one ordinary star among countless others, no longer special in its sky. That is the tragedy of trying to find it. The planet may still exist, but the trail has gone cold across billions of years. There is no glowing line showing where it went, no tail, no continuing orbit around the Sun, no simple prediction that lets us point a telescope and say, there it is. A bound planet leaves an orbit. An ejected planet leaves a mystery. If it was still bound to the Sun, we could search for the way it pulls on distant objects. We could look for the slow motion of a faint world against the background stars. We could try to calculate its orbit. But if the planet escaped completely, then it no longer needs to influence the present solar system in a direct, measurable way. Its strongest evidence may not be where it is now, but what happened when it left. That means the lost planet may be physically real and scientifically unreachable, at least for now, maybe forever. This is different from searching for a distant ninth planet still orbiting the Sun. A hidden planet in the outer solar system is difficult to find, but it would still be part of our local system. It would still have a path around the Sun. It would still be gravitationally tied to us. An ejected planet is a far more difficult kind of object. It is not merely faint, it is detached. It has become part of the galaxy's population of free-floating worlds. And free-floating worlds are extremely hard to study. They do not shine like stars. They do not sit near a bright parent star that tells us where to look. They do not reflect much sunlight because there is no nearby sunlight. They can sometimes be detected through gravitational microlensing when they pass in front of a distant background star and briefly bend its light. Or they might be detected through their own faint infrared glow if they are young or warm enough. But an ancient, cold, rogue ice giant would be a very difficult target. It would be dark in visible light, faint in heat, lost among enormous distances. The planet may be huge and still hidden. This is one of the most unsettling things about space. Size does not guarantee visibility. A star is visible because it produces light. A planet is usually visible because it reflects light or blocks light. Remove the star, remove the nearby light, and a planet can become almost invisible no matter how large it is. A giant world can drift through the galaxy like a black ship on a black ocean. If the lost planet is out there, it may be hiding not because it is small, but because it has no lamp. The Sun used to be that lamp. Now it is gone. At least, gone as a meaningful source of light. So what would the planet itself be like? If it was an ice giant, it would not have a solid surface like Earth in the simple sense. Uranus and Neptune are not rocky planets with a clear ground under a thin sky. They have deep atmospheres, layers of hydrogen, helium, methane, water, ammonia, and other compounds under extreme pressure. As you descend, gas gradually becomes denser and stranger. The boundary between atmosphere and interior is not like stepping onto land. It is a transition into pressure. A lost ice giant would carry that kind of deep structure into the dark. Its outer atmosphere would be colder than it once was. With no nearby sun, the upper layers would receive almost no external heating. The planet would be warmed mainly from within, by the heat left over from formation and slow internal processes. This inner heat could leak outward over time, perhaps creating a faint infrared glow. But on the outside, the world would be unimaginably cold by human standards. The clouds, if visible under enough light, might look different from what they once did. Methane and other compounds could condense or freeze in ways shaped by the extreme cold. The atmosphere might settle into layers. Winds might weaken, or perhaps continue in deep patterns powered partly by internal heat. Giant planets are not simple balls of gas. They can have weather driven by internal energy as well as sunlight. Even far from a star, a giant planet might not be completely still, but without light, almost none of that would be visible to human eyes. A storm can exist in darkness and still be hidden. A cloud layer can move without anyone seeing it. A planet can have weather without a sunrise. That is one of the strangest images of the lost world. Storms in a sky no star illuminates. If the planet retained internal heat, it might glow faintly in infrared. Not like a star. Not brightly, but enough that a sufficiently advanced telescope close enough might detect warmth against the cold of space. The planet would be radiating away ancient energy, slowly cooling over billions of years. It would be like an ember from the solar system's birth, carried into the dark long after the fire that formed it faded. This makes the planet feel less dead. It may not have sunlight, it may not have a surface like Earth, it may not have life, but it could still have an interior history, deep pressure, slow heat, layered chemistry, perhaps a magnetic field if its interior motion allowed. 1. Perhaps auroras if it interacted with charged particles in interstellar space, though without a strong nearby star. These would be very different from the auroras we know. A rogue, giant planet is not just a frozen ball. It is a hidden world with most of its story buried beneath darkness. But from a human perspective, it would still be almost impossible to use or visit, even if we somehow knew where it was. Reaching it would be far beyond our present ability if it has drifted far from the sun. It would not be part of any familiar route. It would not have a star to guide us. It would not offer sunlight for power. It would be a cold destination in a vast dark region between stars. The lost planet may be scientifically fascinating and practically unreachable. That is a common pattern in the universe. The most interesting things are often not close enough to become places for us. Where it is now depends on the speed and direction of its escape. If Jupiter ejected it with enough energy to leave the sun, it would continue moving relative to the sun and the surrounding stars. Over billions of years, its motion would be shaped by the gravitational field of the Milky Way. It might pass through regions with different star densities. It might move through dark interstellar space, perhaps through or near clouds of gas, perhaps across spiral arm regions over galactic time. But most of its journey would be empty. Not empty like the void between galaxies, but empty enough. Interstellar space is far richer than intergalactic space, but compared with a planetary system, it is still almost nothing. Stars are separated by light years. Planets are tiny targets. Dust is thin. Gas is diffuse. A rogue planet could spend billions of years without anything dramatic happening. It could simply continue, dark and cold, while the galaxy changes around it. This is why the lost planet's present could be quieter than its past. Its ejection was the dramatic event. Its exile may be mostly silence, a violent beginning followed by billions of years of drift. That contrast makes the story feel even more haunting. The solar system's early chaos may have launched it away in a brief era of instability, but once it escaped, the drama ended. No explosion, no visible trail, no continuing battle, just motion through the galaxy. The planet becomes a memory, moving through darkness. If it had rings, they might not survive unchanged. Rings are delicate compared with planets. They can spread, fall inward, be disrupted by moons, or be stripped during close encounters. A violent ejection could disturb them. Over billions of years, ring systems can evolve dramatically. The lost planet may have once carried rings and lost them, or it may still have faint debris close to it. We cannot know. If it had moons, their survival is one of the most interesting questions. Close moons might remain. Distant moons might be stripped. The ejection event, especially if it involved Jupiter, could disturb the planet's satellite system. The lost planet might have escaped with a few moons still orbiting it, or it might have been left completely alone. If moons survived, they would become part of a miniature exiled system, a dark planet and its companions moving through the galaxy without a star. That possibility deserves its own deeper question, because a moon system could change everything about what the lost planet became. Moons can create tides. Tides can create heat. Heat can keep interiors active. And in some cases, hidden oceans may exist under ice. This does not mean the lost planet became habitable in any Earth-like way. It would not have warm beaches, blue skies, or sunlight on water. But it raises a stranger possibility. A lost planet, or a moon around it, could remain internally alive in ways the surface would never reveal. For now, the important point is that the lost world may not be only a cold symbol. It may still be physically complex. A planet can be exiled and still keep layers. It can be dark and still keep heat. It can be invisible and still be massive. It can be gone from the solar system and still carry the chemistry of the sun's beginning. That is why the lost planet is not just a missing object. It is a possible time capsule. If we could somehow study it, we might learn about the early outer solar system. We might learn what materials existed where the ice giants formed. We might learn whether it resembled Uranus or Neptune, or whether it was different. We might learn what kind of planets the sun almost kept. But that is the cruel part. The planet that could teach us about the solar system's beginning may be the one the solar system sent too far away to study. Its value as evidence may be enormous. Its accessibility may be almost zero. This is why scientists must work with indirect clues instead. They study the worlds that stayed. They model the early orbits. They examine the Kuiper Belt. They compare the solar system with other planetary systems. They ask whether an extra ice giant makes the story more likely. They try to reconstruct an ancient event from the architecture left behind. The lost planet itself may never answer. It may be too far away, too cold, too faint, too mixed into the galaxy's darkness. And yet, the idea remains powerful because rogue planets are real possibilities in the galaxy. Planetary systems can eject worlds. Young systems can be chaotic. Giant planets can scatter smaller planets. A world can lose its star and continue moving through space for billions of years. The lost fifth giant, if it existed, would be one example of a wider truth. Planets are not always permanent citizens of the systems that form them. Some become wanderers. This changes how we imagine the Milky Way. The galaxy is not only stars with planets orbiting them, it may also contain planets between stars, dark worlds moving through interstellar space. Some may be small and rocky, some may be gas giants, Some may be ice giants. Some may be young and warm enough to glow. Others may be ancient and cold, almost invisible. The space between stars may contain more worlds than the eye can ever see. That thought is both beautiful and unsettling. Beautiful, because it means planets are not confined to the bright neighborhoods of stars. Unsettling, because many of those planets may be completely cut off from warmth and light. The lost planet from our solar system, if real, would be one of the most personal versions of that idea. It would not be just any rogue planet. It would be ours, in origin. A world born from the same ancient disk that built the planets we know. A world shaped by the same young sun. A world that may have moved among Jupiter, Saturn, Uranus, and Neptune before being thrown away. It would be a piece of our own history wandering where we may never follow. That is what makes its current location feel almost painful. It is somewhere. But that somewhere may not matter to us practically. The planet may still be real, but reality is not the same as reachability. A world can exist beyond our ability to find it. It can carry answers beyond our ability to ask them. It can be part of our past and still be unreachable in our future. The lost planet may be one of those worlds. A possible answer traveling through darkness without a question reaching it. If we imagine it now, billions of years after escape, the scene is almost completely still. The planet turns slowly. Its atmosphere, if still present, lies in deep cold. Internal heat leaks outward. If moons survive, they circle in darkness. The sun is a distant star somewhere behind the long path of time. The Milky Way surrounds it with countless lights, none close enough to be home. It is not dead in the sense of being gone, but it is removed from every familiar kind of belonging. That may be the final form of the lost planet. Not destroyed, not hidden nearby, not waiting for return, but transformed into a dark, free-floating world, carrying the memory of a solar system it no longer belongs to. And this makes the next question even more fascinating. Because if the planet still exists, then perhaps it did not leave completely alone. Maybe it carried moons. Maybe those moons were torn away. Maybe deep inside the planet, heat still remains. Maybe under frozen layers, strange hidden oceans could have survived for a time. If the lost world became a rogue planet, then the real mystery is not only where it went, it is what it managed to keep. That is the next mystery of the lost planet. Because being thrown out of the solar system would not mean everything around it vanished in the same instant. A planet is not only a single object. A giant planet can be the center of its own smaller system. It can have moons, rings, a magnetic field, deep layers, internal heat, possibly hidden chemistry that continues long after sunlight is gone. So, if the lost fifth giant planet really escaped the sun, the question becomes stranger. Did it leave alone? Or did it carry pieces of the solar system with it into the dark? A giant planet does not travel through space like an empty sphere. It has gravity of its own. That gravity can hold moons, dust, and debris. We see this clearly in the solar system today. Jupiter has a whole family of moons. Saturn has rings and many moons. Uranus and Neptune have moons as well. Around the giant planets, there are small worlds orbiting larger worlds, like miniature systems inside the greater system of the Sun. If the missing planet was similar to Uranus or Neptune, it may have had moons too. Not necessarily huge moons, not necessarily many, but it could have had companions, small icy bodies captured or formed around it, moons moving through the cold outer solar system before the ejection. A local system of objects bound not to the sun directly, but to the planet itself. And, during the violent instability, those moons would have faced a dangerous test. A planet can be ejected from the solar system and still keep some moons, but it depends on the details. How close did it pass to Jupiter? How far out were the moons? How massive was the lost planet? How strongly were the moons bound? A close moon, deep inside the planet's gravity, has a better chance of surviving. A distant moon is more vulnerable. Jupiter's gravity, or the gravity of another giant planet, could strip it away. The ejection would not be gentle. The lost planet may have passed near other giants before the final escape. Each encounter could pull at its moon system. Some moons might be disturbed into tilted or stretched orbits. Some might collide. Some might be pulled away and left behind in solar orbit. Some might later be scattered by other planets. Some might fall into the planet. Others might survive and follow it into interstellar space. So the lost planet's exile could have happened in different ways. It might have escaped completely alone, a giant world with no companions, stripped clean by close encounters. Or it might have carried one or more moons with it, turning the ejection into the loss of an entire small planetary system. That second possibility is haunting, because then the solar system did not lose just one world. It lost a planet and its sky. From the surface of a surviving moon, the view would become almost unimaginable. The giant planet would hang overhead, enormous and dark. The sun would slowly fade over time, from a powerful central star into one light among many. The other planets would disappear into distance. The familiar architecture of the solar system would be gone. There would be no ordinary day, no season controlled by the sun, no sunrise that warms the surface. Only the giant planet, the stars, and the long darkness between them. If the moon were icy, its surface would freeze even harder. If it had once received a little sunlight, that energy would fade to almost nothing. But moons can have another source of energy, not sunlight. Tides. If a moon is squeezed by the gravity of its planet, or by interactions with other moons, its interior can warm. This happens in our own solar system. Some icy moons are active, not because they are close to the sun, but because gravity flexes them from within. That means a moon around the lost planet could, in theory, remain internally warm for some time. Not warm like Earth, not bright, not open to sunlight, but warm enough in hidden layers to keep ice from becoming completely solid everywhere. Maybe, under the right conditions, a buried ocean could survive beneath a thick frozen shell. This is only a possibility, a fragile one. It would depend on the moon's size, composition, orbit, internal heat, radioactive elements, and tidal forces. If the moon's orbit became too circular and quiet, tidal heating could weaken. If the moon was too small, it could freeze through. If the ejection disrupted the system too much, the moon might be lost entirely. But the idea cannot be dismissed simply because the planet has no star. Sunlight is not the only possible source of warmth in the universe. That is one of the strangest lessons from icy worlds. A surface can be dead, while an ocean hides below. A world can be frozen outside and active inside. Darkness does not always mean simplicity. If the lost planet had moons, and if one of those moons retained enough heat, then the ejected system might have carried hidden liquid water into interstellar space. Not an ocean under a blue sky, not waves under sunlight, not a world like Earth, but a deep ocean trapped under ice, warmed by gravity or internal heat, sealed away from the galaxy. A secret ocean traveling between stars. That image is both beautiful and unsettling. Beautiful because it suggests that worlds can carry complexity even into darkness. Unsettling because such an ocean would be almost impossible to know. It would not reflect sunlight. It would not show clouds from far away. It would not announce itself with continents or weather. It would be buried under ice, around a planet no longer tied to a star, moving through distances we may never search. A hidden ocean could exist and remain forever unknown. Of course, the lost planet itself might also contain deep layers of exotic fluids under pressure. Ice giants are not made of ordinary ice cubes. The word ice in astronomy often refers to compounds like water, ammonia, and methane, mixed into deep interiors under enormous pressure and temperature. Inside a planet like Uranus or Neptune, matter exists in forms very different from anything on Earth's surface. A lost ice giant could keep strange, deep layers for billions of years, slowly cooling in the dark. It would not need the sun to maintain all of its internal structure. Large planets are slow to cool. Their interiors can hold heat for very long times. That heat is not enough to make the surface comfortable, but it is enough to make the planet more than a frozen shell. Deep inside, pressure remains, chemistry remains, heat flows slowly outward. The planet continues evolving in silence. This is why the idea of the lost planet being simply dead may be too simple. It would be dead to sunlight, dead to seasons, dead to the solar system, but not necessarily physically inactive. It could still rotate. It could still have winds. It could still release heat. It could still have layers of strange material moving below its atmosphere. It could still have moons, and those moons could still be shaped by gravity. A rogue planet can be lonely and complex at the same time. That combination is what makes it so interesting. If the planet had rings, they would face their own fate. Rings are fragile compared with planets. They can be disrupted by moons, collisions, radiation, and gravitational encounters. A close pass with Jupiter could disturb or strip ring material. Some ring particles might fall inward, some might spread outward, some might be lost completely. Over billions of years, a ring system could fade, rearrange, or vanish. So if the lost planet once had rings, we do not know whether it still does. It may have escaped with a faint dark ring system, invisible without nearby light, or it may have lost its rings during the chaos. Either possibility adds to the sense that the ejection was not just a clean change of location, it was a violent transformation of the planet's entire environment. A world can survive and still be changed forever. This is true for the planet's atmosphere too. If the lost world was massive enough, it could hold a thick atmosphere even after leaving the sun. Gravity would help keep gases bound, but the atmosphere would cool dramatically. Some compounds might condense, clouds might sink or freeze. The upper atmosphere would receive less energy. Winds and chemistry could change. The planet's appearance under sunlight, if we could bring a light to it, might be very different from what it looked like when it belonged to the early solar system. It may have become darker, colder, less reflective, more hidden, and yet, deep inside, pressure and heat could preserve a world that is not simple at all. This is one of the main differences between an ejected giant planet and an ejected small rocky planet. A small rocky planet without a star may freeze quickly at the surface. It may lose atmosphere depending on its mass and history. It may become a dark, frozen body, though even rocky rogue planets could retain internal heat under certain conditions. But a giant planet has more mass, more insulation, more gravity, and more internal energy. It can carry its own deep environment more effectively. That makes a lost ice giant especially mysterious. It is not habitable in the way people usually imagine, but it may be internally persistent. It carries a kind of private universe beneath its clouds. The most interesting question is whether that private universe could support anything like life. This must be treated carefully. We do not know if the lost planet existed. We do not know if it had moons. We do not know if any moon kept an ocean. We do not know if the chemistry would be suitable. And even if water and heat existed, life is not guaranteed. Life requires more than liquid water. It requires chemistry, energy gradients, stability, and time. Still, the possibility is fascinating, because it suggests that being far from a star does not automatically remove every interesting environment. A moon with a subsurface ocean, protected by ice, warmed by tides or internal heat, could be one of the few places in deep darkness where chemistry continues. It would not need sunlight directly. Some life on Earth exists around deep-sea vents, using chemical energy instead of sunlight. That does not prove life exists elsewhere. And it certainly does not prove life on a lost moon, but it expands the imagination. A dark world could have hidden energy. A frozen moon could have internal water. An exiled system could carry more than just cold rock. This makes the lost planet feel less like an object and more like a possible lost environment. Not just a planet removed from a map, but a whole set of conditions thrown into darkness. Maybe a giant atmosphere, maybe moons, maybe rings, maybe tidal heating, maybe hidden oceans, maybe chemistry continuing under ice, maybe nothing alive, but still something complex. And all of it separated from the sun forever. That separation is what makes the question so emotional. If a moon around the lost planet did have an ocean, that ocean would never see the sun again. It would be sealed under ice, moving through interstellar space, carried by a planet that once belonged to our solar system. It would be part of our origin story, and yet almost impossible to reach, observe, or confirm. A lost ocean, around a lost planet, from a lost version of the solar system. This is not the main claim of the hypothesis, but it is one of its most haunting possibilities. The original idea is about architecture. The solar system may have once had an extra giant planet that was ejected during instability. But once we imagine the planet as a real world, the story becomes richer. Real planets have details, they have structures, they have possible moons, they have histories. They are not just masses in simulations. The fifth giant planet, if it existed, was not only a gravitational object, it was a world. That matters. Because in simulations, a planet can be represented by mass, orbit, and velocity. But in reality, that mass could have clouds, storms, layers, moons, rings, and deep heat. The event we describe as ejection may sound like a line changing in a computer model, but physically, it could mean an entire planetary system being torn from the sun. A whole world family becoming unbound. This is the human side of the science. We know the math matters most for proving whether it happened, but when we imagine the event, we cannot help turning the numbers into a scene. A giant planet moving through the young outer solar system, moons circling it, other giant planets pulling at it. Jupiter, growing brighter during a final encounter, the orbit changing, the sun slowly falling behind, the planet carrying whatever remains into the galaxy. And if moons survived, they would continue circling, in darkness, for billions of years. There is something almost impossible to grasp about that timescale. If the lost planet was ejected early, then its moons, if any remained, may have spent most of solar system history without the solar system. They would have missed everything we know: the cooling Earth, the formation of stable oceans, the rise of life, the oxygenation of the atmosphere, the age of dinosaurs, the appearance of humans, the first telescopes, the first spacecraft. All of that happened while the lost system drifted away. A moon that once belonged indirectly to the sun would have become a moon of the dark. If it had geological activity, that activity would occur unseen. If it had an ocean, that ocean would move under ice, without light. If it had cryovolcanism, or fractures, or tides, those events would happen in a place where no sunlight makes them beautiful. Beauty would exist without an audience. Complexity would exist without being known. This is one of the deepest ideas in space documentaries. The universe does not need observers to be strange. The lost planet could be strange right now, and no one would know. It could have a moon with a dark, frozen surface cracked by ancient tides. It could have a faint magnetic field interacting with the interstellar medium. It could have storms moving slowly through black clouds. It could have an interior still cooling from the birth of the solar system. Or it could be a stripped, silent giant, alone and simple in the dark. All of these are possible shapes of uncertainty, and uncertainty is part of the story. We cannot make the lost planet too certain because it remains hypothetical. We cannot give it confirmed moons. We cannot give it confirmed oceans. We cannot give it confirmed life. But we can explore what such a world might plausibly keep, based on what giant planets and icy moons can be like. It may have kept gravity. It may have kept an atmosphere. It may have kept moons. It may have kept hidden complexity. What it definitely lost, if ejected, was the sun. And losing the sun changes almost everything. The sun is not only light, it is a clock, a source of external energy, a center, a definition of orbit, a reason for seasons, a gravitational identity. When the lost planet escaped, it lost that central relationship. Whatever it kept without a star. This is why the planet's survival would be so different from Earth's survival. Earth survives because it belongs close enough to the sun, inside a stable orbit, with the right conditions at the surface. The lost planet survives because it is massive, insulated, and self-contained. Earth's life depends strongly on sunlight at the surface. A lost ice giant, or its moon, would depend on internal heat, tides, and deep chemistry if anything interesting remained. Two completely different meanings of survival. Earth survives by being held in the right place. A rogue planet survives by carrying enough with it after losing its place. That is the theme that connects this chapter to the larger story. A thrown-out planet is not erased. It becomes a test of what a world can keep when it loses its star. The answer may be more than we expect, but less than we would hope. It can keep mass, it can keep gravity, it can keep deep pressure. It can keep some heat. It may keep moons, it may keep hidden oceans, but it cannot keep sunlight. It cannot keep a normal year. It cannot keep the solar system. It cannot keep home. That final loss is the largest one, because home, in a cosmic sense, is not only where a planet formed, it is the system of relationships that holds it in place. The sun, the planets, the smaller bodies, the shared gravitational architecture. Once the lost planet escaped, those relationships were broken. Even if it carried moons, even if it kept heat, even if deep hidden layers remained active, it was no longer part of the solar system's living structure. It became a survivor without a home. And perhaps that is the best way to imagine it now. A survivor. Not a corpse, not a myth, not a confirmed object, but a possible survivor from an earlier, more violent solar system. A giant planet that may have carried parts of its own system into darkness. A world that may still be turning somewhere between stars. A world that may still be cooling slowly after billions of years. A world that may have kept more than the solar system intended to lose. If such a planet exists, it would be one of the most haunting relics imaginable. Not because it would be easy to see, but because it would represent a version of our solar system that no longer exists. A version with one more giant planet. A version more crowded, more unstable, more dangerous. A version that had to change before the system we know could emerge. This is why the lost planets, moons, and oceans matter, even if they remain speculative. They force us to remember that the missing planet was not just a mathematical tool. It was a possible world with its own lost history. And that lost history may be tied to ours. Because if the fifth giant planet helped stabilize the outer solar system by leaving, then its exile may have helped create the conditions under which Earth remained safe enough, long enough, for life to continue. The lost planet may have kept moons. It may have kept heat. It may have kept hidden oceans. But the most important thing it may have given away was stability. Not intentionally, not for us, not as a sacrifice with meaning at the time, but through the blind consequences of gravity. One giant planet left. 4 giant planets remained. The outer solar system settled. And far inside that system, one small rocky planet continued moving around the sun, Earth. That is where the story becomes even more personal. Because the thrown-out planet may not only be a mystery about something lost, it may also be part of the reason something else survived, Earth. That is where the story of the lost planet becomes more than a mystery about the outer solar system. Because if a 5th giant planet was once thrown away, then its disappearance may have helped shape the quiet structure that Earth depends on today. Not directly, not magically, not because the planet left for Earth's sake, but because in a gravitational system, the fate of one world can change the fate of many others. A planet lost in the dark may have helped create a solar system where Earth could remain stable. That idea feels strange at first, because Earth seems so far away from the outer giants. We live close to the Sun, on a small rocky planet between Venus and Mars. Jupiter is far beyond the asteroid belt. Saturn is even farther. Uranus and Neptune are deep in the cold outer regions. A missing ice giant would have belonged even farther from our daily experience. So it is easy to imagine Earth as separate, a little blue world with its own story. But Earth is not separate. Earth is part of the same gravitational architecture as every other planet. The solar system is one connected structure. What happens in the outer system can change the paths of comets. It can disturb small bodies. It can change impact rates. It can affect how stable the planets remain over long periods of time. Even if the giant planets never come close to Earth, their gravity shapes the environment Earth lives inside. Distance reduces influence. It does not erase it. This is why the lost planet matters. If the early solar system had one extra giant planet, the system was more crowded. More massive bodies were competing for stable orbits. More gravitational relationships had to settle. The outer planets may have crossed paths, migrated, and disturbed the disk of icy objects. In that kind of system, long-term peace is not guaranteed. Something had to change. The extra planet may have been the change. If it was ejected, the remaining giant planets could move toward a more stable arrangement. Jupiter, Saturn, Uranus, and Neptune could settle into orbits that did not repeatedly threaten one another. The outer solar system could become less crowded. The most unstable large body could be removed. Over time, the system could quiet down. And that quietness matters. Earth needs time, not just a few million years, not just enough time to cool, but billions of years of relative stability. Life on Earth did not appear as cities, animals, forests, and intelligence all at once. It required a long chain of conditions. Oceans had to persist. The planet had to remain in a stable orbit. The sun had to provide steady energy. Impacts had to become less frequent over time. Atmosphere, chemistry, geology, and biology had to interact across ages. Complex life is slow. A solar system that remains too chaotic for too long may not give a planet like Earth the time it needs. This does not mean Earth required a perfect environment. Earth has survived impacts, climate changes, volcanic episodes, extinctions, and deep transformations. Our planet's history is not gentle, but there is a difference between a difficult world and an impossible one. Earth could survive hardship because the larger architecture around it remained stable enough. The sun kept shining. Earth kept orbiting. The giant planets stayed in their distant places. The inner solar system was not constantly destroyed by planetary chaos. That stability may be the background miracle of our existence. We often focus on Earth's local conditions: water, atmosphere, magnetic field, plate tectonics, the moon, the right distance from the sun. These are important, but behind all of them is a larger condition that is easier to forget. The solar system had to remain orderly enough for Earth to keep being Earth. If Jupiter had ended up in a very different orbit, Earth's story might be different. If Saturn had disturbed Jupiter more strongly, the inner planets might have been affected. If Uranus or Neptune had been thrown inward instead of outward, the flow of small bodies could have changed. If an extra giant planet had remained on an unstable path, the entire system might have stayed dangerous. The missing planet, if it existed, may have been part of the reason that danger ended. The idea is not that Earth was directly saved in one dramatic moment, like a hero pulled from disaster. It is subtler than that. Earth may have survived because the solar system found a stable arrangement early enough, and that stable arrangement may have required losing a giant planet. This is a different kind of survival story. Not one where Earth escapes a single impact. Not one where Jupiter blocks one comet, but one where the whole system settles into a shape that allows long-term habitability to become possible. The lost planet may have been removed so the architecture could stop changing violently. Once the fifth giant left, the remaining planets had more room. The giant planets could stabilize their spacing. The outer disk could be sculpted. Neptune could finish shaping the Kuiper belt. The small bodies that remained could settle into reservoirs. The most dangerous period of large-scale rearrangement could fade, and far inside, Earth could continue. This is why the phrase, "Earth survived because of this," has to be understood carefully. It does not mean scientists know that without the lost planet's ejection, Earth would definitely have been destroyed. We do not know that. There are many possible early histories. Some might still allow Earth to survive without a fifth giant. Others might not. The lost planet hypothesis is one possible path to the solar system we see today. But if that path is correct, then Earth's long-term stability may be connected to a world that is no longer here, a planet we never saw. A planet that may have left before life became complex. A planet whose absence may be part of why our presence became possible. That is a haunting connection, because it turns the lost planet from a distant object into part of our own origin story. The early solar system was not only building planets, it was choosing, through blind gravity, which arrangements could last. Unstable systems do not remain unchanged. Crowded planets interact. Orbits shift. Objects collide or escape. Over time, the system removes possibilities that cannot survive. What remains is not necessarily what was first born. It is what could endure. Earth endured. But Earth's endurance may depend on the endurance of the whole system around it. Think about the inner planets. Mercury, Venus, Earth, and Mars are small compared with the giant planets. They live closer to the Sun, where orbits are faster and more tightly bound. But they are still sensitive to long-term gravitational influences. The giant planets, especially Jupiter and Saturn, can affect the stability of the inner solar system over very long timescales. Small changes in the giant planets' orbits can echo inward. This does not mean Jupiter is constantly pulling Earth into disaster. It means the architecture matters. A slightly different Jupiter and Saturn could produce a different long-term environment. A more eccentric Jupiter, a different Saturn relationship, a stronger instability, a prolonged period of scattering. All of these could change the inner planet's history. Over millions and billions of years, small differences can become meaningful. The solar system is stable, but not because gravity is weak. It is stable because the current arrangement works. The lost planet, if it existed, may have helped the system reach an arrangement that works. That is the deeper point. The present solar system is not random in the simple sense. It is the result of a history that filtered out unstable configurations. If a fifth giant planet made the outer system too crowded, it could not remain forever. It either had to find a stable orbit, collide, be swallowed, or leave. Ejection is one way the system removes instability. A thrown-out planet may be a sign that the solar system solved a problem by losing a world. The problem was crowding. The solution was exile. The result was stability. This sounds almost cruel, but gravity has no cruelty. It has no mercy either. It only has consequences. And consequences can create worlds like ours. The same early instability that threatened the solar system may have helped shape it into something durable. The movement of the giant planets may have scattered icy bodies, changed impact rates, and rearranged the outer regions. That process may have been dangerous, but after it ended, the system was calmer. In that calmer system, Earth had time. Time to cool. Time to collect oceans. Time for chemistry to become biology. Time for life to survive catastrophes. Time for simple organisms to become complex ecosystems. Time for consciousness to look back and ask why the solar system is the way it is. Without time, Earth is just a planet. With time, Earth becomes a living world. That time may be one of the greatest gifts of the solar system's final architecture. Not a gift given intentionally, but a condition created by stability. This is why a missing planet can matter more than it seems. The story is not just about what the solar system lost. It is about what the loss allowed the solar system to become. If the removal of the fifth giant reduced chaos, then the absence is part of the reason the remaining structure lasted. A missing world can create space. A missing world can reduce danger. A missing world can help the survivors settle. In human terms, we might call that sacrifice. But in cosmic terms, it is not sacrifice. It is selection by gravity. The system tried many possible motions. The unstable ones did not last. One planet may have been removed, the others remained. Earth continued inside the outcome. This is important because it keeps the story scientific rather than magical. The lost planet did not leave so life could exist. It left, if it existed, because its orbit became unstable. Earth survived if connected to that event because the resulting system became stable enough. Meaning comes later. Physics came first. Still, it is hard not to feel something when we think about it. Somewhere, perhaps, a dark planet is drifting through the Milky Way. It may have been born around the same sun. It may have once shared the same early disk as Earth. It may have been part of the ancient gravitational family. And now it is gone, while Earth remains warm, blue, and alive. One world lost the sun. Another world kept it. That contrast is powerful. It reminds us that planetary systems are full of unequal outcomes. Some worlds become gas giants. Some become frozen moons. Some become scorched planets. Some become dead deserts. Some are swallowed by stars. Some are thrown into darkness. Some remain in just the right place long enough for life to appear. Earth is one of the rare outcomes where stability, chemistry, distance, and time all came together. The lost planet, if real, is one of the outcomes that did not stay. The two stories may be linked. This does not make Earth special in the sense of being chosen by the universe, but it does make Earth precious. Precious because the conditions that let it remain habitable were not guaranteed. Precious because the solar system's calm may have been earned through ancient chaos. Precious because our blue sky may exist inside an architecture shaped by lost worlds. Every day on Earth depends on things that happened before Earth became familiar. The moon's formation, the cooling of the crust, the delivery or retention of water, the long-term brightness of the sun, the stability of Earth's orbit, the positions of the giant planets, the clearing of dangerous debris, the settling of the outer solar system, and perhaps the ejection of a fifth giant planet. Most of these events are invisible in daily life. When we stand under the sky, we do not feel Jupiter's ancient roll. We do not feel Neptune's migration. We do not feel the possible absence of a lost planet. We feel sunlight, weather, ground, and air. We experience Earth as immediate and complete. But Earth is built on deep history. The present is supported by ancient events we never see. That is what astronomy reveals. It pulls the hidden foundations into view. The lost planet is one of those hidden foundations, if the hypothesis is correct. It may have helped make the solar system less crowded. It may have helped preserve Uranus and Neptune by becoming the planet that was removed instead. It may have affected how Jupiter and Saturn reached their modern relationship. It may have influenced how the outer disk was scattered and how the distant small bodies were arranged. All of this affects the environment Earth inherited, not in a simple straight line, but in a web. A change in the outer planets changes the outer disk. A changed outer disk changes the population of small bodies. A changed small body population changes impacts and reservoirs. A changed giant planet arrangement changes long-term gravitational stability. A changed stability changes the time available for Earth. The web is complex, but the message is simple. Earth's survival may depend on more than Earth. That is one of the humbling truths of planetary science. A planet is not only a world, it is a member of a system. Its fate is tied to bodies far away. Its stability can depend on giants it never touches. Its history can be shaped by events beyond its sky. Even life, which feels so local and intimate, exists inside a cosmic architecture. The grass, oceans, clouds, cities, animals, and human thoughts of Earth all depend on a planet continuing around the Sun without being thrown into chaos. That quiet orbit may have required a violent past. This makes the solar system feel less like a perfect machine and more like a survivor's arrangement. Not designed, not peaceful from the beginning, but stabilized after instability. The asteroid belt is not a neat garden. The Kuiper belt is not a simple edge. The Oort cloud, if present, is a distant reservoir of scattered ancient objects. The giant planets may have moved. The small bodies may have been flung everywhere. The inner planets may have endured impacts. The system we know may be the cleared and settled version of something once far more crowded. The solar system is not only 8 planets, it is the aftermath of everything that did not remain. The lost 5th giant planet is the largest possible example of that. A whole world that may have been part of the original arrangement, then removed from it. And by being removed, it may have helped define what remained. This is why the lost planet story should not be treated like a simple monster mystery. It is not just, where is the missing planet? It is, what did losing that planet allow the solar system to become? That question reaches all the way to Earth. If the 5th giant had stayed, the outer solar system might have remained unstable. If it had disturbed Jupiter and Saturn differently, the inner solar system might have faced stronger gravitational effects. If Uranus or Neptune had been ejected instead, the Kuiper belt and outer architecture would be different. If the instability lasted longer or happened differently, the timing of impacts and scattering could change. There are many possible histories. We live inside one, and in that one, Earth survived. This survival is not total safety. Earth has been struck by large objects before. Life has nearly been reset many times. Extinctions have shaped biology. Climate has swung between extremes. The planet is dynamic and sometimes brutal. But the solar system did not become so unstable that Earth was thrown away, driven into the sun, or made permanently uninhabitable by constant catastrophic bombardment. That relative calm is enough. Life does not require a perfect universe. It requires a universe stable enough for long enough. Earth got that. Maybe because the solar system lost something that could not stay. This is where the lost planet becomes almost like a shadow behind every peaceful orbit. When Earth circles the sun today, it does so inside a system that has already resolved its earliest giant planet chaos. The planets are spaced. The giant worlds remain distant. The most dangerous ancient rearrangements are over. The sky appears predictable enough that we can build calendars, spacecraft trajectories, and theories. Predictability is a late-stage luxury. The young solar system may not have offered it. The lost planet's ejection may have been one of the events that made predictability possible. If so, then the darkness that swallowed that planet is connected to the light that reaches Earth every morning. Not poetically only, dynamically. The same gravitational history that sent one world away may have helped leave another world in place. That is difficult to hold in the mind, because the two outcomes are so different. The lost planet enters interstellar darkness. Earth receives sunrise. The lost planet loses the sun as a center. Earth remains centered perfectly enough for seasons, climate, oceans, and life. The lost planet becomes unreachable. Earth becomes home. Two paths from the same ancient disk, one kept, one lost. If the fifth giant existed, it may have been made of the same general solar material as the other planets. It formed from the disk around the young sun. It was part of the same birth environment. In that sense, it was a sibling of the worlds we know, and like many siblings in a chaotic early system, it did not end up with the same fate. That makes the solar system feel less complete than it looks. The list of planets is a present tense list. It tells us what orbits the sun now. It does not necessarily tell us every planet the sun once had. That distinction is central to this entire story. When we say the solar system has 8 planets, we are describing today's architecture. But if the lost planet existed, the deeper history includes another world, a planet that was there in the beginning, then removed before the final map was set. The solar system's present is not the same as its full biography, and Earth's presence may be linked to that missing biography. This idea also changes how we think about safety. We often imagine safety as the absence of danger, but in planetary systems, safety may come after danger has already removed what could not remain. A stable system can be the end product of instability. A calm orbit can be the result of ancient scattering. A habitable planet can exist because the larger system stopped being chaotic. Earth's safety may not mean the solar system was gentle. It may mean the violence happened early enough for Earth to recover and continue. That is an important distinction. If the giant planet instability happened too late, it could have been disastrous for a developing biosphere. If it happened early, before complex life, the system could settle afterward. The timing of instability matters. The lost planet's ejection, if part of early solar system evolution, may have occurred before Earth became the living world we know. That timing would allow Earth to inherit the calmer aftermath. Again, this is not certainty. It is a possible story built from models, observations, and the need to explain the system's architecture. But as a narrative of planetary survival, it is powerful because it shows how life can depend on events far beyond its immediate world. Life on Earth may owe something to Jupiter, something to Saturn, something to countless icy bodies scattered long ago, and perhaps something to a planet that was removed. Not because those things cared about life, but because they shaped the arena where life later appeared. The lost planet's greatest effect on Earth may have been absence. By not being here, it allowed the system to be less crowded. By leaving, it allowed the remaining giants to settle. By becoming a rogue planet, it may have prevented a different instability from continuing. Absence can be an active part of history. We see this in many systems. A missing object can explain a pattern. An extinct species can shape an ecosystem long after it is gone. A removed mass can change the motion of what remains. A vanished planet can leave an architecture behind. The absence is not nothing. It is part of the structure. The lost planet is absence with gravity, or rather, gravity that once acted and then left. That is why the story is so haunting. The planet may no longer pull on Earth today in any meaningful way, but its ancient departure may still be part of why Earth's sky is calm enough for us to study. A missing world may be hidden inside the conditions of every ordinary day. The sun rises, Earth turns, the moon moves around us. Jupiter shines at night, Saturn follows its path, Uranus and Neptune continue far away, and somewhere, maybe, a former planet of the sun drifts in darkness, no longer counted, no longer seen, no longer connected, except through history. It is a quiet thought, but it changes the whole feeling of home. Home becomes not just the place that kept us. Home becomes the outcome that remained after other outcomes failed. That is not a reason for despair. It is a reason to understand how rare stability can be. The universe may contain countless planets, but not every planet keeps a peaceful orbit for billions of years. Not every system settles in a way that protects its inner worlds. Not every world gets enough time. Some are thrown out. Some are swallowed. Some are sterilized. Some never form at all. Earth's story depends on a long chain of survival. The lost planet may be one broken link that somehow made the rest stronger. Or, perhaps it is better to say, one unstable link removed so the chain could hold. This is the kind of thought that makes the solar system feel deeper than a classroom diagram. The planets are not just objects in order from the sun. They are survivors of a history. Their order is the final shape of ancient motion. Their calm is not guaranteed. Their existence is not the whole story. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and maybe, once, another giant. A giant that did not stay. If that giant had stayed, would Earth still be here? Maybe. Maybe not. Science cannot answer that with a simple yes or no. But the question matters because it shows how connected planetary fate can be. Earth's habitability is not only a local accident, it is system-wide history. We live not just on a planet, but inside a successful arrangement of planets. That successful arrangement may have required failure elsewhere. The failure of an orbit. The failure of a fifth giant to remain bound. The failure of the early solar system to keep every world it formed. And from that failure, a stable system emerged. This is not comforting in the usual way, but it is profound. Because it means the solar system we know is not a perfect original. It is a survivor. And Earth is one of its survivors too. The more we follow this idea, the more the lost planet becomes a mirror for our own good fortune. It shows what could have happened to a world born around the sun. It shows that planets can lose their stars. It shows that large worlds can be removed. It shows that stability is not automatic. And by contrast, it makes Earth's continued presence feel extraordinary. Earth did not simply appear in a safe system. The system became safe enough, maybe through chaos, maybe through the loss of a planet. And then, after all that, life had time to begin. This is the emotional center of the ninth part of the story. The lost planet may be gone, but its absence may be part of why we are here to wonder about it. That does not mean we should imagine the planet as a martyr. It had no awareness, no purpose, no decision. But it does mean we can see the solar system as a network of consequences. The ejection of one giant planet may have changed the architecture that later supported Earth's long-term stability. That is enough to make the missing world matter, not only as a mystery, but as part of the hidden foundation of home. And once we understand that, the final idea becomes clear. The solar system we see today is not necessarily the full solar system that began. It is the version that survived. The calm, beautiful structure around us may be the remaining shape after migration, scattering, instability, and loss. The planets we know may not be the complete original family. They may be the ones that gravity allowed to stay. And the lost planet, if it existed, may be the clearest reminder of that truth. The solar system is not only what is here, it is also what had to disappear for this version to exist. That is the final truth behind the lost planet. When we look at the solar system today, it feels complete. We see the sun at the center. We count the 8 planets. We draw their orbits as clean rings. We place the asteroid belt between Mars and Jupiter. We place the Kuiper belt beyond Neptune. We imagine the whole system as a finished structure, like a cosmic machine that has always looked this way. But that picture is only the present. It may not be the full story. The solar system we know today may be the surviving version of something older, messier, and more violent. A system that once had more material, more collisions, more small worlds, more unstable paths, and perhaps one more giant planet. A planet large enough to shape the early outer solar system, but not stable enough to remain inside it. If that planet existed, then the solar system has a missing chapter. Not a missing asteroid, not a missing moon, not a small icy body that wandered away. A whole giant world. A planet that may have formed around the sun, moved among the other giants, crossed into instability, passed too close to Jupiter, and escaped into interstellar darkness. That possibility changes the way every planet feels. Because the planets we see are not simply a list of objects. They are survivors. Mercury survived near the sun. Venus survived as a world of heat and pressure. Earth survived in the narrow region where water could remain and life could grow. Mars survived as a small, cold planet with a scarred surface and a lost past. Jupiter survived as the gravitational giant. Saturn survived with its rings and moons. Uranus survived tilted and distant. Neptune survived at the edge of the planetary system. And maybe, once, another giant planet did not survive as a member of the Sun's family. Maybe it became the one that left. This is what makes the lost planet hypothesis so haunting. It does not only add a mystery to the solar system, it changes the meaning of the solar system's calm. The quiet order around us may not be evidence that nothing dramatic happened. It may be evidence that the drama already ended. The chaos is not visible because the system has settled. The missing world is not visible because it is gone. The scars are not obvious because they are written in orbits, distances, and absences. The early solar system was not a perfect clock. It was a place of growth, impact, migration, and instability. The giant planets may have shifted, Neptune may have moved outward. Jupiter and Saturn may have changed their relationship. Small icy bodies may have been scattered in enormous numbers. Some objects may have been sent inward. Some may have been thrown outward. Some may have been ejected from the sun completely. In that kind of system, losing a planet is not impossible. It is extreme, but not impossible. And if the lost planet was real, then the solar system we inherited is not the original arrangement. It is the arrangement that remained after gravity removed what could not stay. That is a colder, deeper way to see our home. A stable system can look peaceful after it has already lost its unstable pieces. A forest can look quiet long after a storm. A shoreline can look calm long after the wave has passed. A room can look orderly after the broken things have been cleared away. In the same way, the solar system can look calm now because the ancient instability is over. The missing planet would be one of the broken pieces gravity cleared away. But unlike rubble, it may not have been destroyed. It may still exist, somewhere in the Milky Way. A dark, giant world moving between stars, no longer warmed by the sun, no longer connected to the planets, no longer part of the map we know. It may have carried moons. It may have kept heat. It may still hold deep pressure and hidden layers. It may be silently cooling after billions of years of exile, or it may be stripped, alone, and almost completely invisible. We do not know. We may never know. But the possibility is enough to make the solar system feel less simple. Because if a planet can be thrown out, then the solar system is not only a collection of worlds, it is a story of selection. Not selection by life, not selection by purpose, selection by gravity. The worlds that could remain, remained. The worlds that could not, left, collided, scattered, or were swallowed. The final map is the map of survival. This idea is important because it removes the illusion of inevitability. The solar system did not have to look exactly like this. Earth did not have to be here. Neptune did not have to survive. Jupiter and Saturn did not have to settle into the relationship they have today. The Kuiper Belt did not have to carry the structure it now carries. The system could have evolved differently. A little more instability, a different timing, a different encounter, a different path for Jupiter or Saturn, a different outcome for Uranus or Neptune. And the solar system could have become something else. Maybe a system without Earth's long, calm history. Maybe a system where Neptune was lost. Maybe a system where Jupiter and Saturn disturbed the inner planets more strongly. Maybe a system where another giant planet remained, and the outer region never settled the same way. There were many possible pasts. Only one became ours. And in our past, perhaps a fifth giant planet was removed. This does not mean the lost planet is certain. It is still a hypothesis, a possible explanation supported by the way some models of the early solar system work better with an extra ice giant. It is not a confirmed discovery. No telescope has found this former world and proven it came from the sun. No spacecraft has seen it drifting between stars. No direct photograph shows the lost member of the solar system moving through the galaxy. The evidence is indirect. The idea comes from trying to understand the system we do see, the positions of the giant planets, the migration of Neptune, the structure of the Kuiper Belt, the survival of the inner planets, the difficulty of building the modern architecture from the early chaos. The fact that sometimes adding one extra giant planet and then ejecting it makes the final system more believable. That is why careful language matters. The solar system may have lost a planet. It could have lost a planet. The fifth giant may have existed. Jupiter may have thrown it away. These words leave room for uncertainty. And uncertainty is not weakness. It is honesty. A mystery is powerful not because we pretend to know everything, but because the evidence points towards something astonishing that still has not been fully revealed. The lost planet is exactly that kind of mystery. It is not a fantasy planet invented only for drama. It is a serious possibility that emerges from the violence of planet formation. Young systems are often chaotic. Planets can migrate. Worlds can scatter each other. Rogue planets can exist. Giant planets can rearrange entire systems. Compared with that larger cosmic reality, a lost fifth giant planet in our own solar system is not absurd. It is possible, and possibility, when the object is an entire planet, is enough to feel enormous. If it happened, the ejection would have been one of the most important events in the solar system's early history. It would have helped define which planets remained. It may have helped the giant planets settle. It may have affected the outer disk. It may have shaped the conditions that later allowed Earth to remain stable for billions of years. A single missing planet could be connected to the whole architecture around us. That is the strange beauty of gravity. Everything is connected, but not always obviously. A planet billions of kilometers away can affect small bodies that later move inward. A migration in the outer solar system can sculpt distant belts and reservoirs. A close encounter between giants can decide which worlds stay and which worlds leave. An event before life existed can shape the conditions for life much later. The past is hidden inside the present. The lost planet, if real, is hidden there too. Not in the sky, but in the structure, in the way the giant planets are spaced, in the way Neptune shaped the outer belt, in the way the solar system survived its dangerous youth, in the fact that the system is calm enough now for us to ask the question. That calm is easy to take for granted. Every day, Earth completes another part of its orbit. The sun rises, the moon moves, the planets continue in predictable paths. Space agencies can send spacecraft across billions of kilometers because the system is stable enough to calculate. Astronomers can predict eclipses, transits, and planetary positions. We live inside an orderly sky. But order is not the same as innocence. The sky may be orderly because disorder was removed. The lost planet may be the clearest symbol of that removal. It reminds us that home is not only made of what stayed close. Home is also shaped by what was pushed away. The solar system became the place we know partly by clearing, scattering, absorbing, and losing material. Most of the original disk is gone. Countless planetesimals no longer exist in their first forms. Many small bodies were sent into new regions. Some were swallowed by planets. Some were thrown out. Perhaps one giant planet joined them. The solar system is a survivor, surrounded by absence. That phrase sounds dark, but it is true in a deep way. Most of the material that once moved through the young solar system is no longer where it began. Planet formation is not gentle assembly only. It is also removal. To build stable planets, systems must clear unstable debris. To reach long-term order, they must lose or rearrange what does not fit. Creation and loss are tied together. The lost planet is the grandest version of that theme. A world created around the sun, then lost by the sun. And if it still exists, the planet may be drifting now under a sky unlike any planet's sky in our solar system. No sun dominating everything. No familiar planets, no bright nearby parent star. Just the Milky Way, distant stars, and blackness. If it has moons, they circle it in the dark. If it has internal heat, that heat leaks slowly into space. If it has deep layers, they continue under pressure. If it has hidden oceans on moons, they remain sealed away. The planet may still be a world, but it is not a home world. It is a relic of an earlier solar system, a moving fossil of a time before the final architecture settled. That is why it is so difficult to think about. It is both part of us and not part of us. It may have formed from the same solar nebula as the other planets. It may have once orbited the same young sun. It may have interacted with the same giant planets. In that historical sense, it would be a former member of our system. But gravitationally, it is no longer ours. It belongs to the galaxy now, and the galaxy is vast enough to hide it forever. Even if we someday discover thousands of rogue planets, identifying this one may be almost impossible. How do you prove a dark planet came from our sun billions of years ago? How do you trace a wandering world through the changing motion of the Milky Way? How do you recover an address after the galaxy has erased the path? The planet may have lost not only the solar system, but its identity. That may be the final cruelty of ejection, not destruction. Anonymity. A world can survive and become unknowable. This is different from a planet that remains far away but bound to the sun. A distant, hidden planet still has a relationship we can study. It tugs on objects. It follows an orbit. It remains part of the local gravitational story. But an ejected planet has taken its strongest evidence with it. Its current path may no longer tell us clearly where it came from. Its past may be easier to infer from what it left behind than from the planet itself. The solar system remembers better than the planet can be found, and that memory is incomplete. We can run simulations, we can observe small body populations, We can refine models of migration. We can discover more distant objects beyond Neptune. We can compare our system with others. Each new piece of evidence can make the lost planet hypothesis stronger, weaker, or more complex. Science does not freeze the mystery in one dramatic shape. It keeps testing it. Maybe future observations will show that a fifth giant planet is very likely. Maybe they will show that the solar system could reach its current form without one. Maybe the story will change. But the deeper lesson will remain. Planetary systems are not static. They evolve. They migrate. They lose worlds. They become what they are through motion. This is true whether or not our own fifth giant existed. The universe is full of planets whose histories are not peaceful. Some migrate close to their stars and become hot giants. Some are trapped in resonant chains. Some collide with other worlds. Some are swallowed by their stars. Some are ejected into interstellar space. A planet's birth does not guarantee its future. Our solar system is part of that larger story. It may look calm now, but it was born in the same universe of gravity and chaos. The lost planet hypothesis brings that reality home. It tells us that even here, in the system we think we know best, there may be a missing world in the past, a giant planet not shown in the modern diagram, a former member that left before there were humans to count planets, a world that could have changed the fate of everything by disappearing. And this is why the story feels so unsettling. The solar system feels familiar because we learned it as a list. But the real solar system is not a list. It is a history. A list says Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. A history asks what happened before that list became stable. A list shows what is present. A history asks what was lost. The missing fifth giant planet belongs to the history. It reminds us that what we know as the solar system may be the edited version, the final visible arrangement, after the early chapters were rewritten by gravity. The planet that was thrown out, if it existed, is one of the edits we cannot see directly. And the most powerful part is that this lost chapter may be connected to us, not because the planet cared about Earth, not because the universe planned for life, but because stable architecture matters. The removal of one unstable giant could help the remaining system settle. The settled system could give Earth time. Time could allow oceans, chemistry, life and consciousness could eventually ask why the system looks the way it does. In that sense, the lost planet may be part of the long chain behind this very question. A world thrown into darkness may have helped leave a world in light. That is not a moral lesson. It is a consequence. And in space, consequences can be more profound than intention. Every peaceful orbit has a history. Every stable system has a past. Every world that remains has survived conditions that could have been different. Earth's calm is not simple. It is layered on top of ancient impacts, migrations, scatterings, and gravitational choices made without a mind. We are living in the aftermath. That is one of the central truths of astronomy. The universe we see is always the aftermath of something. The stars are aftermaths of collapsing gas. Planets are aftermaths of disks and collisions. Moons are aftermaths of capture, impact, and formation. Earth's surface is the aftermath of volcanism, oceans, atmosphere, and life. The solar system is the aftermath of formation and instability. And perhaps the empty place where a fifth giant planet might have been is the aftermath of ejection. The absence itself becomes part of the story. It is easy to think of absence as nothing. But in the solar system, absence can be meaningful. The gap between Mars and Jupiter tells a story of failed planet formation and Jupiter's influence. The distant scattered objects tell a story of Neptune's movement. The small icy reservoirs tell a story of ancient scattering. A missing planet if required by the architecture, would tell a story of instability powerful enough to remove a world. Absence can speak through structure. That is why scientists listen to orbits. An orbit is not just a path, it is a memory of forces. It carries the record of what has pulled, disturbed, trapped, or scattered an object. The solar system is full of these memories. Some are easy to read, some are faint, some are mixed with many events. But together, they allow us to reconstruct the past, at least partially. The lost planet may never be seen, but the orbits may still whisper that something was there. This is the kind of mystery that fits deep space best. It is not a mystery solved by one dramatic reveal. It is a mystery built from slow evidence, careful models, and the unsettling realization that the present is incomplete without the past. The missing planet is not frightening because it might return. It is not a danger waiting outside Neptune. It is frightening because it shows how unstable the beginning may have been. It shows that a planet can lose its star. It shows that a solar system can lose a giant. It shows that what survives may only be a fraction of what began. And it shows that our own home may be built on an ancient loss. If the lost planet is still out there, it is probably not watching us, not approaching us, not sending any signal. It is simply moving, silent, cold, dark, a world with no sunrise. Its journey may continue for billions more years. It may pass near stars and remain uncaptured. It may drift through regions of the galaxy where no one will ever see it. It may cool until its heat becomes almost undetectable. It may become one of countless dark planets between stars. And yet, if it came from here, it carries an origin unlike any random rogue world. It carries the beginning of our solar system. It carries a connection to Jupiter's ancient power. It carries a possible explanation for why the giants survived as 4 instead of 5. It carries in its absence a connection to Earth's long stability. That is why the planet matters, even if we never find it. Some objects matter because they are present. Others matter because they changed what is present and then left. The lost planet belongs to the second kind, a cause without a visible body, a world-shaped absence, a former planet of the sun, perhaps, now hidden in the galaxy. By the end of this journey, the question is not only whether the solar system once had another planet. The deeper question is what kind of place the solar system really is. Is it a perfect, finished design, or is it a survivor's arrangement? A system that passed through chaos, lost what could not remain, and settled into the calm we now mistake for eternal order. The evidence points to a solar system that changed. A solar system where giant planets may have moved. A solar system where the outer regions were reshaped. A solar system where small worlds were scattered. A solar system where a planet may have been thrown away. That does not make our home less beautiful. It makes it more real. Beauty does not require a peaceful origin. Sometimes beauty is the shape left after violence ends. The rings of Saturn, the blue of Neptune, the silence of the Kuiper Belt, the stability of Earth, the bright sun in our sky. All of these belong to a system with a deep and complicated past. The solar system is beautiful, not because it was always calm, but because it became calm enough for beauty to be noticed. We are part of the noticing. That may be the final wonder. The early solar system had no observers when the giant planets moved. No eyes saw the possible 5th giant planet swing too close to Jupiter. No one watched its orbit stretch into escape. No one saw the sun shrink from its sky. No one marked the moment it stopped being one of the sun's worlds. But billions of years later, on a planet that remained, life learned to look backward. We cannot see the event directly, but we can imagine it through science. We can read the architecture, we can test the models, we can ask what had to happen for this version of home to exist, and the answer may include a lost giant planet. a world thrown out of the solar system. If it existed, it is not a threat now. It is not waiting to return. It is not a secret planet that will suddenly appear in our sky. It is more distant than that, more ancient than that, more tragic than that. It is a possible relic of the solar system before the solar system became familiar. A reminder that the map we know is only the final page we can see. The earlier pages may include chaos, migration, close encounters, scattered worlds, and one giant planet leaving forever. This is the truth the lost planet leaves behind. The solar system is not only a home, it is a history of survival, and survival always implies that something else did not survive in the same way. The lost fifth giant planet, if real, survived physically by becoming a rogue world, but it did not survive as part of the solar system. Earth survived differently. Earth stayed. Earth remained near the sun. Earth kept receiving light. Earth became a world of oceans, continents, clouds, and life. One world left the light. One world lived under it. That contrast is the emotional center of the whole story. When we look at Earth, we are seeing one outcome of the early solar system. When we imagine the lost planet, we are seeing another. Both may have begun around the same young sun. Both may have been shaped by the same disk. Both may have felt the gravity of Jupiter and Saturn. But their paths separated. One path led to home. The other led into interstellar darkness. And somewhere in that contrast is the reason this mystery matters. It makes the familiar strange again. It makes the solar system feel alive with missing history. It makes Earth feel less automatic. It reminds us that stability is precious, not guaranteed. And it shows that sometimes the most important planet in a story is the one that is no longer there. That is the story of the planet that may have been thrown out of our solar system. Not a confirmed world in our telescopes, not a hidden planet waiting just beyond Neptune, but a possible lost giant from the violent youth of the sun. A world that may have helped shape the solar system by leaving it. A world that may still be drifting somewhere in the Milky Way. Cold, dark, and unnamed. And if it is out there, then it carries one of the oldest secrets of our cosmic home. The solar system we see today may not be the original family. It may be what remained after one planet was lost. Thank you for watching this journey into the lost history of the solar system. If you enjoyed this calm exploration of deep space and ancient planetary mysteries, subscribe to the channel for more space documentaries like this. Leave a like if you want more long journeys through the hidden history of the cosmos, and write in the comments what impossible space mystery you want to explore next. Tonight, you were watching the Space for Sleep channel, talking about the planet that was thrown out of our solar system. Sleep well and keep looking up. Good night.